like as some of the space that I've been kind of like working on in the last few years is more looking at issues of infrastructure resilience and sustainable development broadly defined. Very quickly, I'm sure like we have seen global climate change models. I mean, global climate change, some of the work that I've done in the last 10 years is working with global simulation models that can simulate like what would be the different scenarios of atmosphere under different kind of like greenhouse gas emission trajectories. So this is from the IPCC report, for example, where these models require massive amount of data sets. And they can simulate 4-dimensional planetary system over hundreds and millions of years, depending on the model scope and so forth. But they can also be used for decision making. And that's where like the United Nations, for example, Conference of Parties meetings are, this model is like a simulated version of a large, more complex model. This is from the Climate Interactive, like John Sterman's place in MIT. They run this for more, making this interactive for the negotiators to use this model actually like during the negotiations on the go. So I just wanted to show this as an example, like how models can be used as decision support systems by, like I think this particular model is used by representatives from more than 30 countries during the negotiations. You can go to their website and download the model. It's open source. So I mean, that's kind of like one way that we can use computer simulation models for decision making and kind of like projecting the uncertainty and kind of like looking at how different interventions can kind of like have an impact. I've also been looking at some of these more like regional scale integrated assessment models that can integrate more global climate change models with agent-based models and hydrodynamic models and lake models in more like complex. NSF has invested millions of dollars in this model in the last few years. I've been fortunate to lead this project. And we have kind of like come up with very specific, very context-specific decision support tool for the towns and the Regional Planning Commission, as well as the state government, the EPA officials, to utilize and understand like how impacts of climate change are going to affect at like spatially distributed manner. So this is a downscale climate change scenario on a random day in 2040. And this is like an agent-based model that can simulate the evolution of land use in an entire watershed. And this is the hydrological model that's connected. And this is the lake model, where like this is the red color shows the algal blooms that can emerge because of the increasing temperature and nutrient fluxes in that system. So this model can simulate on a daily time scale, the evolution of the lake system, the hydrology, depending on the condition of the land use and the climate change. And the decision makers can use this model to understand like what are the management implications of like doing X versus Y. So I just wanted to start with this because I think these are like some of the technologies that are overlooked in our kind of like discussion about AI and big data, like how they can help government, but people kind of like get into the frenzy of Cambridge Analytica, but ignore these kind of like long-standing approaches that have been at the core of decision making and have taken up in the government, and we've been working with the government agencies at many levels. This is just one example. There are many, many examples. I've seen like over the years, Bob Axel present so many models, and so it's just like an entire growing area, like both in the agent-based modeling, in the network analysis, in kind of like other kinds of integrated assessment models and so forth. So I'm just going to skip these. These are like some of our forecasts. I know Brad is going to talk about it a little bit, but I just wanted to set the stage. Some of the slides are, but the autonomous vehicles, for example, autonomous vehicles is another disruptive technology that, as I was talking about earlier on, like can have a lot of benefit for like an aging society. As the baby boomers are retiring, we need, and older people don't want to give away their car keys. They just want to keep on driving. But I think the autonomous vehicles can provide a way to reduce the accidents. I mean, that's been demonstrated. But at the same time, autonomous vehicles can also be fooled. Like if somebody replaces the stop sign and changes just slightly, the sensors that are on the system can be fooled through kind of like a strategic manipulation. Or the onboard computer system can be hacked if it's not cyber secure. So I mean, all of those kind of like risks are there as well as their potential benefits. So how do you go about weighing the pros and cons of these autonomous vehicles? Also, like drones, like drone warfare. Like I come from Pakistan, we have seen U.S. drone warfare in Afghanistan tribal region Like that was a pilot test ground there, but it's also been used drones in other places. But there is no international drone treaty at this point of time. But the question is, like, say, if other people start using drones on the US land, or like already Heathrow Airport has drone intrusions and other airports are getting intrusions just from the hobbyists, but it could also be strategic warfare. So what is the global international treaty for drones look like? So these are some of the issues in terms of autonomous vehicles that we need to think about. Drones are also being used in precision agriculture. They're also being used for mapping, like at very high level LiDAR technology. So there's a lot of potential, but at the same time, there's a lot of risk. And I think quickly, in terms of the workforce development, I sent you a report. I just wanted to highlight that came from the IBM Center for Government just last month. And kind of like, I know that Dan would have a lot more to say about it, but just wanted to highlight their key findings that in terms of the workforce development, I mean, this does not even include Government Accountability Office, which I'm sure like you will hear a lot how they are using the data sets. But I think the Department of Treasury, I mean, these are the numbers, the number of people affected by the AI technology. But I think, as we heard earlier on, like it's been known since the days of Herbert Simon. I mean, those of you might have read Sciences of the Artificial. That kind of like started this discussion, like how the workforce development would evolve in response to these artificial intelligence technologies. And he kind of like puzzled with the idea of like routine versus non-routine, and like what is programmable versus non-programmable tasks that would need to be accomplished, and can AI start doing non-programmable or tasks, and like in terms of like strategic development and versus the routine tasks already are being done by many like AI like apps and so forth in the e-governance arena. So a lot of this discussion is like how the workforce, what is the future of the workforce, given that AI technologies can be used to augment the policymakers and decision makers, or they could also be used to kind of like mislead them. So because there are hackers can get into those. So these are all the issues that we have to think about. Then there was this report that Kevin D'Souza wrote. He's in Australia right now for the IBM Center, and kind of like he gave an overview. This is my like last set of slides before I hand over to Paul. Like, I mean, he kind of like provided a nice overview. It's like a couple of years old, but he kind of like talked about the IT infrastructure, like you might have heard about the debates of 5G now these days, like how the Chinese are kind of like gaining some kind of competitive advantage over US in terms of like these fast infrastructure. Like if you happen to be in Korea, I mean, South Korea, you would see like their internet speeds are already way faster than what we have here. So the IT infrastructure, the legacy is the challenge. I mean, how do you replace that? And especially in places like Vermont, where I come from, there was a recent study that was done. About 80% of the rural areas are not, the IT companies say that they have the coverage there, but actually they don't. So when you have like AT&T and Verizon, you don't get access. And many people, so there is a question like internet haves and internet not haves, or digital haves and digital not haves, because the problem is that if you don't have access to internet service, how would you access or utilize in an interactive with these technologies? So there are a lot of other kind of like more specific challenges in terms of like interoperability and project management capabilities. So there is a lot of opportunity because of these challenges. We can take a lot of action to improve that infrastructure in a nutshell, but that would require investment and resources. Similarly, in the workforce development I already alluded to, I think that government there needs to be some kind of reform package to think about like how government training of the MPAs or training of the in the workforce, people who are actually in the government, needs to be enabled to kind of like, we can't wait for these technologies to go back, because I think if you look at the report that just came out last month, a lot of the older people are going to be the ones that would be affected. Like if you look at this distribution of the age, like the people who would be affected according to this analysis. So we can't wait these people to retire and then train the new workforce development. I think there needs to be some kind of like an infusion of AI and big data training in the existing workforce if we want to overcome this challenge. So how do we go about doing that? I think this is a question that's critical for ASPA and NASPA. That's kind of like part of this discussion. So I think I will wrap it up by just my final comment here is about some of these issues in terms of cybersecurity, like how do you, the risk management, I mean, so there are risks and benefits, but how do you manage the risks that these technologies pose? And clearly, I mean, I think Kevin D'Souza like nailed it in the sense that cybersecurity, we need to have that capacity. But cybersecurity is becoming more and more complex with new technologies like quantum computing or quantum cryptography can like overcome some of these other technologies. And I sent you an article to trust the AI or robots that came out in Scientific American as preparation for this. And these are issues that, you know, like even established programs cannot handle these kind of like technologies. So where we are going with that. And then issues of like ethical and social consideration and governance of these technologies, I'll hand over Paul to take it away. I mean, he's gonna say a few more words about that.
Thanks. Thank you, Asim. Yeah. There's so many different dimensions that we can talk about, and I think you'll hear us probably all talk about slightly different dimensions that I think respond to some of the things that you've put forth in your introduction. So I'm Paul Hirsch. I'm an associate professor. I'll stop sharing this here. So I'm associate professor at the State University of New York. I teach leadership, ethics, and decision making. And what I want to do is kind of zoom in and think about this question of what is the role of AI, the potential of AI in supporting various aspects of governance and governance decision making, and just think about some of the tensions, issues around that, and provide just some concepts we're thinking through that may or may not support some of the other discussions. When I think about decision making in a governance process, specifically as opposed to a private setting, it's very clear that decision making must unfold in such a way that it has to uphold the collective good. That's very clear. And that's not a one-shot deal. That requires building trust and building community and building institutions and building that fabric that decision-making relies on over time. So particularly when, as is often the case in a lot of governance settings where we have both, on the one hand, deep uncertainty about the world and what's going to happen if we make certain decisions, and also value conflicts. Making decisions in those contexts is not just a question of coming to the best possible decision. It's also a question of doing it through the appropriate process. And Asim mentioned, you know, Herbert Simon, who also a long time ago makes this distinction between substantive and procedural rationality. Substantive being decision-making that achieves the goals we want through the optimal means, or the best means. Procedural meaning making the decision through the appropriate process. And that process is designed to support the range of goals that we need to uphold, not just in that specific decision, but in the wider institutions and society that we're a part of. So the question then becomes, what is the role of artificial intelligence? And in this type of process, particularly in a governance setting, that demands both substantive, you know, Asim was showing some really great substantive tools, right, to help us make better substantive decisions, but it also requires procedural and maybe other types of rationality as well. So I want to just see if we can flesh out and zoom in on the types of decisions that people working in a governance context must navigate, and that AI, if it's going to be in that context, must also navigate, or perhaps partner with people in the right way so that they get navigated. So I want to think of these decision scenarios as entailing the navigation of trade-offs in 3 different dimensions. So trade-offs in 3D is what I'm saying is we have to look at for governance decision making. And the first dimension is the knowledge dimension. In any decision in a governance setting, there's a lot of moving parts. There's things that are known, there's things that are unknown, and decisions have to unfold that take into account of what is known, that try to perhaps through big data increase what is known, but also make decisions in spite of the unknown. So there's the knowledge dimension. The second dimension is the values dimension. There's multiple and conflicting agendas. Decisions play a role in the public values, the public good at multiple scales. And some of our values are explicit, we know what they are, and some we learn through the process. And so somehow AI and or humans have to deal with these multiple and conflicting value sets. And the third dimension is, we can call it the political dimension. Within any decision process in the government setting, there's always things going on at multiple scales, and one decision doesn't just mean something for that decision, it means something in multiple ways and in multiple contexts. Again, some explicit and some quite hidden. And in that, some people always have more of a voice and more of an access to influence the decision-making process and more information and knowledge that gives them the tools to do so. So a government decision maker must navigate each of these dimensions really simultaneously. And that decision maker themselves has material interests, has pre-existing values and biases, and they're themselves embedded in multiple political processes. So when we think of AI, perhaps artificial intelligence can mitigate some of the tensions and challenges that come up with this, but I think it's important to think it through. So if we're in the knowledge dimension, you know, thinking about the role of AI, we have to deal with these epistemological questions, right? How does the AI, and I think Brad and others will get into this, but can an artificial intelligence really know what it needs to know in order to make complex decisions? What is the role of big data in that? And once we get to ethics, can artificial intelligence meaningfully integrate different values which may be incommensurable? Or maybe there's a way to commence them, to put them in a common metric, but maybe the people who have those values don't feel so good about everything being measured according to a common metric. At the dimension of politics, I would say there's another type of question, and this is what I think I'm personally most interested in. We can call it an ontological question, but really that's to say, what does it mean? What are the implications that it is not a human, or not only a human, but another form of intelligence that is navigating these multi-dimensional trade-offs on the public's behalf? And at this third dimension in particular, we have to recognize that, again, that a significant part of the decision process is not coming to the right answer, but it's reassuring a conflicted and uncertain public that the process itself can be counted on to uphold our values for democracy and for fairness, irrespective of the specific outcome. So again, it's important to pay attention not just to the intrinsic properties of the decision process itself, but to that process as part of a social system, and to pay attention to the impacts of that decision process on that larger system. Do we want to know, for example, that a decision maker has to struggle with trade-offs? Do we want to see the furrowed brow on the part of a decision maker that's real? I was in the room. I had a friend who's struggling with cancer, and I happened to be in the room with him and his doctor talking about whether to continue chemotherapy or not, and all the, you can imagine, horrible implications either way, or just deep uncertainties. And the fact that there was a human being that was willing to acknowledge to my friend that he's an expert doctor at one of the top places, but he didn't have the answer, he didn't know the right decision, that somehow his acknowledgement of the uncertainty and the deep conflicts that he was experiencing allowed my friend to, I think, own that situation and his own decision in a way that wouldn't have been possible had not the doctor acknowledged in his very being the humanity that he was bringing to the situation, in addition to his deep expertise. And so I wonder, you know, and I'm sure he was relying on all sorts of algorithms and tools and apps and things as well. But how do we make sure that that role is in there? Myself, you know, I just to give another example, maybe we can all relate to, I'm the graduate coordinator in my department, and I have to weigh all these things, who gets funding, who doesn't. And there's so many values at play, some of which are explicit, some which are not. And I can imagine an artificial intelligence learning through a process of what are these values to play, and how do I allocate these different values. And it would probably be good for us as a community to have to make explicit all the different values that are sort of hidden and kind of vague, and probably intentionally so. It would probably be good for us to have to make those explicit. And yet at the same time, I think having me as someone to blame for failure, or me as someone that can call somebody and say, hey, I know you got kind of didn't get what you needed now, but I'll make sure you get what you need in the future. All those human dimensions that go into having a real decision maker who can take accountability for this conflictual, uncertain, morally ambivalent process is difficult for me to think about what role an artificial intelligence plays in that aspect of the decision process, particularly, again, in a governance setting. So I'll just end to say, you know, as a decision maker, again, you know, we've been debunking the notion of perfectly rational decisions in governance for a long time. And artificial intelligence seems to be saying, hey, we can make these more rational decisions. Well, given that decisions are imperfect, what is the role of AI in imperfect decision making? Can AI make decisions in the public interest and be a part of a meaningful moral deliberation when all these uncertainties and ambiguities are on the line? So I just wanted to present that as a context for some of these discussions that we get into. And I think from here, I'll pass it back to you to open it up to the panel.
Yeah, so thank you so much. And we'll have we want to have a round of questions for the panelists. And after each round of question, we'll go through and we'll have then a chance to interact and you can ask questions as well. So that's the plan of action. So I think my first question, which we have shared the question, but I'll just repeat that. It's like, like in terms of like, what are the challenges and opportunities for public service in terms of these artificial intelligence and big data technologies that are coming our way. So probably like, maybe we can go with Rob, Dan, Brad, and David. Is that good way? And then we can go to Jane.
And just take like 5 minutes, something.
Yeah, that's fine.
So yeah, so maybe just by way of background, let me just mention that I spent it public policy, so-called think tank. So I was deeply engaged in public policy more than I am now as a professor. But it seems to me that one of the great pathologies about public policy that you learn in Washington is that many public policies fail because they're built on crappy social science. Basically, they have a model of how the world works, and it's basically the wrong model. And they build policy on top of that, and so the whole thing comes crashing down when they're trying to arrange human affairs in some particular way, and they have the wrong understanding of how that works. So it seems to me that the great thing about living through public policy issues today is that we do have this revolution going on today in the social sciences, where between data and computing, we're just getting a much more detailed, nuanced, more scientifically grounded understanding of how the basic social world works. And so it gives us the opportunity, at least, to do much better policy. Whether we do it or not is a different issue. And so, in particular, I think that it's at least, and I work mostly in economics these days, but in economics we have this kind of tripartite revolution of data coming both from large-scale administrative data, so call that big data. I mean, my astronomer friends say that social science data is not big data because it's not petabytes or exabytes. So it's only terabytes. But basically, when you have all the data on all, for example, I've been working with data on all American business firms. So all firms that file taxes, we can get access to their data, and you can study the firms' their tax returns, for example. That is the universe of all data, and so that is as big as the data you get. So between the data and the universe of data, and then being able to do experiments. And so my colleague at George Mason, named Vernon Smith, he won the Nobel Prize about a dozen years ago for doing experiments with human subjects. And so we can get data both from these comprehensive databases and then from human experiments, and then to mix that in with computing, we can now really build models of every individual entity, person, thing, company, whatever, in a social environment. You can really do things that were unimaginable before. Now, it is fair to say, I think that today because we're only living through the birth of this new approach to social science, all bets are off in terms of how to actually manage it properly, how to do it properly. Just to be very concrete about that is that yes, of course, data is the foundation of all of it, but there are these new fields growing up, the new broad field called data science, also known as data mining, machine learning, and there are many degree programs even around this town between George Washington and George Mason and Georgetown. Georgetown has the massive data institute. Many universities are trying to get the data. UVA just got $100 million from an alumni to build a data science program. So data science, just an example of how we're in the startup phase. What is data science? Nobody really knows what data science is. Well, why is data a science? What are they? Why is it not just applied statistics? So nobody really knows what data science is, but we don't get to do more of it just because we're swimming in data, right? So maybe one way to think about it, at least from the point of view of building better policies, is to say, can we build? What kind of models do we need? Let's eventually model individual people and doing whatever they do, how they respond to policy, for example. How do we build models that can ingest or digest this kind of micro data? So basically, what we have are micro data. We never had that before. When I was a graduate student, we only had aggregate data. There was no such thing as micro data. Today, I have data on every firm. Google has data on all of us, right? What our purchasing habits are. So how do we eat micro data? And so we need to have a new class of models. These kind of, as you mentioned, agent-based models is one kind, but the other kinds of things, microeconometrics. So there are a variety of ways you can deal with these things. But now you get into privacy problems, right? The privacy concerns that can you readily identify the data. For example, for one concrete example, so I was involved in a project in the wake of the financial crisis to build models of housing market bubbles. And so the conventional model would be, what are the incentives that a representative household would face when they're confronted with, say, low interest rates and the housing prices are going up or whatever. You would write a model for what a typical firm would do. Sorry, a typical household would do. But what I think that what we did was different was we basically got data on every household in a particular city. So we had basically every house, the housing stock. We had every family from a detailed micro sample. We had basically all the mortgage data from the big mortgage service provider. So basically, we were able to build a model of 2 million households. But now that those data are, of course, deeply non-private. I mean, we tell what Mr. Smith paid for his house and what how far Mr. Jones was behind in his mortgage payment. We knew all those things, right? And so those are the kinds of privacy issues that we're confronting today with as we get into having essence of microscopic data on all of us, right? And I think that we don't know how to deal with those things today. So once we're at the birth of a new era, and we don't know how to deal with that. When it comes to AI proper, which is kind of beyond the data, I just have a couple observations. One is that I was a graduate student at Carnegie Mellon when I would call, we're in something like the third wave of AI. This is the conventional wave. I was a student of Herbert Simon. Okay, so Herbert Simon, one of the fathers of artificial intelligence. The first wave was this early thing that didn't go. So John McCarthy, Herbert Simon up at Dartmouth. The second wave really was when I was starting my graduate school career. It was kind of at its apogee, and basically it came crashing down. And some of you will know that it's called the AI. The second AI winter was this now late '80s time, early '90s time. And basically, people had overhyped AI. They said, well, expert systems will solve all of our problems. Right? So all a doctor needs is a better diagnosis tool, and he'll be able to tell you whether you have, whatever you have. He'll know it. So people do a better job than the doctor. I think that one of the lessons we learned from the second AI hype and subsequent winter was that basically AI is not a silver bullet. It's not going to solve all of our problems. Right? It's yet one more technology. And I think that today, arguably, there's certain kinds of things that have been overhyped and hyped too far. And we'll probably see this kind of backlash on the power. Having said that, there are certain things that are certainly useful that we can do, and say just even be able to deal with large amounts of data is very important. And for example, so deep learning. I don't know how, at least when it comes to some of the deep learning papers, those sound a lot like hype today. I can talk more about that if we have time. But of course, there are some technologies that seem to be quite fertile. But then they also have the drawbacks. For example, so blockchain technologies. Blockchain technologies are an interesting way to do privacy and an interesting way to do a whole bunch of security and other kinds of a whole bunch of nice features. But they're also processing like 6 transactions a minute, where the Visa system is processing 600,000 transactions a minute. So they have their bandwidth constrained at the moment, and we don't know how to make them go faster. And so they have some nice properties, they also have some crappy properties. And so once again, we're at the birth of a new era. We don't know what these things are going to ultimately be useful for, I think. And so it's important to push forward on all of them, but I think we have to just be realistic about them. And my final point to wrap up for now anyway is that when it comes to workforce issues, here it turns out that actually there's been a lot of previous work, and I think some of it is not always understood by people who are talking about this stuff these days. For example, the first wave of automation really happened in the 1950s when things like, just a concrete example would be something like, in the 1940s in a petroleum refinery, there would be tens of thousands of workers all walking around to every pump and station and turning gauges and stuff. And then by the time the 1960s rolled around, big companies like Honeywell and things that made automatic controllers, where they took the jobs away eventually, all those, so you get a whole refinery could be run by a dozen people. And that was an early example of automation. There are many other examples contemporaneous with that one. And so it turns out that our old friend Herbert Simon, he wrote about this at the time, and he said, maybe we shouldn't. He said it's a mistake to think about automation, or now about AI displacement of workers, as in terms of its absolute advantage. So basically, here's what he's saying. Say, don't worry about the fact that AI can do things better than you, or better than you as a mid-level manager in the federal workforce. Yet we have to think about it in comparative terms. So this is now what's going on. I'm an economist, so we have to go back to international trade, right? So a simple example is, England can make better machines than France, but France makes better wine than England. Okay, so they trade machines for wine, right? Now, what happens if all of a sudden this climate change, which there was, turns out in 1500, and you could grow grapes in London? Okay, so what if you can grow wine suddenly? And you can produce wine in London? Does that mean the French are going to now suffer? Well, the answer is no, right? Because the French wine is still better than the London wine. Okay, so the French can still make wine, compared, relatively speaking, better than the English. So the fact that it's not an absolute advantage; it's relative advantage. So we shouldn't worry, it seems to me, so much anyway, about the fact that machines can do things better than us, because what we should worry for, what it's going to displace is the thing of, the things that we can do better than machines would just be brought to the fore. We will basically provide to the machines the things that we can do better than them, right? And there are always going to be things that we can do better than them in the foreseeable future. Just as a footnote, right? When AI comes with the kind of AI we have today, right? It's not really AI. That's human intelligence being reproduced computationally, right? And the way that Deep Blue, when I was a graduate student, Deep Blue was actually deep thought, and then just apropos earlier discussion, deep thought at Carnegie Mellon was basically as the second AI winner hit, there was no funding for deep thought, and so IBM bought the whole deep thought team and became Deep Blue. So Deep Blue ended up beating Kasparov using a very different algorithm than the actual chess player does. You may have heard that recently AI algorithms can now beat Go players, Go, a much more complex game than chess. But it's basically using a more elaborate search techniques. It's not reproducing human intelligence. It's doing something quite different. And then you may have heard that last year for the first time now, the computational player, AI player, is now the champion poker player in the world. So but once you're using a quite different cognitive engine than what is believed to work in cognitive science. So there are always going to be things in the near term anyway that humans can do better than the machines. And so I personally am not very concerned about AI displacement. So I'll stop there.
That's great, Ron. Thank you so much. This is perfect. So Dan, you want to take up?
Sure. So obviously, my VM, I have a blue shirt on, but I'm wearing a yellow tie. You talked about the first phase of AI. One of the things, and some of you may have seen this, last year was the 50th anniversary of 2001, Space Odyssey. And there's a bit, actually, it so happens that the guy who played the lead actor, Dave, is a family friend of my family. And he's been traveling all over the world with Hal, the computer, going to exposés and expositions and talking about sort of the vision of artificial intelligence that they went into the movie with. And
is it the original Hal, by the way?
The
original Hal wouldn't even work anymore.
Yeah, it's sort of, Hal is sort of a state of mind. But Keir Delay, the actor, has been fascinated by the interest in popular culture in artificial intelligence. So this is really permeating both the work that we're doing here in public administration and government, but it's also something that people are living with every day, and they're seeing sort of played out in how they do shopping, how they travel. We talked about different examples of that. So I think that we're definitely seeing a burgeoning of not just AI, but of, as I talked about earlier, about sort of different applications of data analytics and the use of emerging technologies to harness those. So just a quick word. So the IBM Center for the Business of Government that Sean was kind enough to show some of our studies. You stole my prop, right? I brought this one as a prop and get the suits as a prop. But we publish reports. Justin Bullock is an author of from our center. Did a great report on risk management in the U.S. government. And Jane Westman is an author who did a report last year on chief data officers for us. So we work with academic experts on sort of addressing topics that are top of mind, challenges for government leaders around the world and in the U.S. And we actually also published a book last year called Government for the Future. I brought another prop, where we had a sort of a chapter in this book called The Future of AI, which was written by David Bray, who is the former CIO for the Federal Communications Commission, and is now the head of the People-Centered Internet Initiative, working with NSERF. So all of our information is available on the website. You can sort of Google Center for the Business of Government and see anything you want. So a lot of the work, as Seem said, that we've done in the last year is focused around AI. We've also done a report on blockchain in government, and we have a number of reports around data analytics and both past and future that we're working on. So to the question of sort of what are the opportunities and challenges, I'll kind of go to the opportunity side a little bit. And I think that the point is well taken around, there's been a lot of technologies that have come along ever since the printing press that have, where we've been worried that the jobs will, the world will end and people will suffer in terms of employment and that sort of thing. And almost always these are economic drivers in terms of the engine, and it takes a while to sort of figure out how to help the workforce adjust to that new reality. But we do as a society kind of keep moving in that direction. And we think, and this is sort of a broad IBM perspective, that AI really, at its best, can augment decisions. It doesn't really replace decisions as much as it enables people to make better decisions and allows them to move from what we call low value, and this was part of the report that we wrote, move from low value to high value work. So if you've got a sort of a repetitive, almost an assembly line kind of data entry model and a compliance model in a lot of government agencies where they're just trying to count stuff, make sure stuff happens and fits into boxes, AI can help automate that so that if you're, let's say, an inspector, if you're an inspector, let's say at NHTSA, the National Highway Transportation Safety Administration, which is right around the corner from here, you no longer have to sift through lots of reports. The AI can kind of isolate, well, this type of car had certain types of accidents, and here are the patterns that show that there might be something in common. Maybe they were all made at a particular plant, and the AI can help the analysts track that back much more effectively than they could if they had to do that by hand. So sort of moving from the lower value repetitive analytics to higher order analytics is one opportunity and benefit that we're seeing. Another is sort of moving to customer service, right? When you call an e-commerce website, you're often talking to a chatbot, and you're seeing government move in that direction. You're seeing more of this technology being used by whether it's the Internal Revenue Service or the Social Security Administration, government agencies that are providing customer service, and much more of this happens obviously at the state and local level, in enabling the government to provide a customer experience that is, if not quite as good, it's moving in the direction of sort of following best practice in the commercial space in terms of providing an excellent personalized real-time interactive experience that with privacy and security built in. So you need to sort of overlay the authentication piece so that, and this is where one of the challenges that we'll come back to, we get to, because it's, just as it's easy to spoof a non-AI system and tell that system that you're not the person that it thinks you are, we need to be careful about building in security and privacy protocols that work at the speed and scale of AI. And that's a challenge. That's something that we don't typically see in sort of the evolution of an introduction of new technology. Usually the efficiency and the throughput is what people think about first, and then the security and privacy folks, and I'm a security and privacy person, so I want this to be earlier. They come in and say, hey, you forgot about this, that, and the other thing. And then you get companies like you're seeing now just today, Facebook announced we're going to be a security and encryption company. And hopefully we'll be able to move that earlier in the evolution of these technologies as we move into the public sector. One of the challenges that this implies is the skill set of public sector workers and companies and researchers working with government to move more from a compliance mindset and into a customer service mindset. And that's both a cultural change as well as a change in sort of skills and interactions that government employees typically don't get in their work. They're typically sort of trained in a rules-based, law-based, compliance-based, as opposed to a service-based and data-based type of model and how they interact with citizens. So that skill change, I think, is both an opportunity as well as a challenge for the workforce. And then the other thing we talked a little bit in the introduction, just around sort of the issues of ethics and understanding bias and making sure that we're transparent about data, and AI kind of magnifies this by a factor of 100 in terms, because the scale and speed at which you can take information, make decisions, enable people to kind of reach a decision. Let's say you're automating a bunch of that rote work, but you're doing it based on data that's flawed, or that there's a bias in the data set because it's based on, let's say, a data set that's disproportionately, and this is one of the famous cases, disproportionately about men who go to work, but now there are many more women in a particular occupation, so it's going to assume things about the categorization of people in that occupation that aren't the reality. So sort of understanding the data, working with data to in a training setting to make sure data are improved. We're seeing this a lot in work we're doing at IBM. For example, we developed an application that was just demoed last week around helping veterans find apprenticeship opportunities and job opportunities. And so we had to make sure the data set sort of matched the profile of veterans coming out of the service today, which is different than the profile that if you had used a 10-year-old data set, it would have looked in terms of that population of veterans leaving the service. So I think there's these challenges. I think the challenges and opportunities are both kind of flip sides in that sense. And I think Kevin D'Souza in his report laid it out very effectively. And I look forward to hearing more from my colleagues here and further discussion.
Thank you, Dan. So
So I'll start off by making this more interactive. Would anyone here be willing to take a nap in an automated Tesla as it's driving down the road? No. It might surprise you to learn that about 11% of surveyed drivers would be willing to do that, which, you know, given the recent data on Teslas driving underneath semi-trucks, getting the top sheared off, it suggests that there is a mismatch of people's understanding in the capabilities of AI systems and what they can actually deliver. So I think of my job as a psychologist, former computer scientist, well, still in some sense, as trying to reverse engineer the human mind for secrets that we can steal from nature to make better artificial intelligence applications. So my perspective, which I'll start off with, is sort of more on the limitations side of AI, because I'm interested in sort of figuring out what AI can't do well yet, so that we can sort of figure out what's kind of missing from that picture. So as has been remarked before, in the past, a lot of what we did to mark improvements in AI was beating people at games. Chess, Go, StarCraft recently, although there's a lot of controversy about that. So the interesting thing about these problems is that we as humans tend to think of them as very hard problems, but in terms of what computers are capable of doing, they're actually the easiest problems to solve, because they have discrete state spaces, and the objective function, or the sort of conclusion of the game, is very clearly defined, right? Whereas a lot of what we do as people exists in a more or less continuous state space that is ill-defined, and with victory conditions, if you want to think of it that way, is not at all being very clear. Like, for example, having a conversation. It's a very difficult thing for people to do, but it seems natural to us. But it's actually really challenging. Our brain is doing a lot of hard work to enable us to have a conversation with someone else in a way. And when we try to build AIs that can have a conversation, we quickly realize how difficult that challenge is. You need to understand the frame of mind of the person you're talking to. You need to be thinking about what you should say in response to them, et cetera. So there's a whole world of things that we do very well, so well that we don't even understand how hard it is to do well. And this is a large part of why the AI field often stumbles in terms of predicting how long it's going to take to do a certain thing, because we underestimate how hard it is for our brain to do things. I'll talk a little bit about some things that, in my experience, AIs have traditionally done pretty badly and still do pretty badly. And this comes more from the deep learning side of the equation, which Rob talked about. So one of the things that we do well that AIs don't do is that we fail gracefully where AIs fail badly, right? So what this means is that when we look at something and we don't know quite what to do, we have sort of fallback strategies that we can rely on to sort of get us out of trouble, and AIs typically don't do that. So let me just show a quick little example here. A lot of the sort of most famous success in AI recently within the artificial intelligence, and from my perspective, a cognitive psychology perspective, has been the way that AIs have been able to understand images. And this is, useful if you're just doing Google image search. You can now put up an image and Google will tell you what's in that image. It seems like a fantastic technology. But it turns out that these algorithms, as impressive as they are, have some very exploitable weaknesses. So this is a phenomenon known as adversarial images, where what you do is you take a given algorithm and so for example, this picture of a car, which we would all agree is a picture of a car, but we would also say this is probably a car showroom. So there's a lot of other things that we would pick up on there. But with a little bit of experimentation, you can figure out that if you add this noise to this image, you end up with this image down here that I think we would all agree is still a car, but an AI would now very confidently, with 99% certainty, claim is a toaster. So we basically fiddled with the pixels a little bit in a way that sort of finds the cracks in the statistical mapping between the AI's representation of pixels and the classification label of a sports car. And we found this sort of like little micro crack that we can navigate with this pattern of pixels that gets us to toaster instead of sports car with an incredibly large amount of accuracy. And this also works in other domains. So here someone was saying, well, here's a picture of a rendered school bus, which the AI is saying, okay, that's a school bus, 100% certainty. Let's figure out what happens if we just rotate that school bus in this three-dimensional space. And here you have garbage truck with 0.99, punching bag, 1.0, snowplow, 0.92. Here, this fire truck, very confidently labeled as a fire truck here, becomes a school bus when you lift it up off the ground. we would think that's insane. Like, who would think that this is a school bus? But yet this is the kind of failures that AIs get into, because they're not really understanding what's there. They're just essentially building a very complicated regression from pixels onto labels. This also translates into the real world. So as C mentioned, this is an experiment to see what you can do to a stop sign to get an AI to think that this is instead a speed limit sign. So I think this is like 2/3 of the time this image was considered to be a speed limit sign, not a stop sign, with obviously very scary implications, because if we have a bunch of Teslas running around, you just put a couple pieces of tape on stop signs and suddenly they're blasting through intersections. There's a lot of potential problems there. So in many cases, we sort of misattribute the complexity of these systems and sort of misunderstand how capable they are, because we sort of evaluate them in the micro context of like this ImageNet competition. And again, when people, like for example, if you showed me a machine from an industrial room and I didn't know what it was, I would still say it's a machine. I wouldn't say that's a picture of a kitten. So even sort of way outside of my expertise zone, I can still come up with some kind of reasonable estimate of what that might be in a sort of broad sense, but also sort of estimate my uncertainty about how far I am out of my depth. So that's one of the things that current AIs don't do particularly well. The other thing is that they don't really get meaning in the sense that we think they do, right? So when we see like show a school bus, we get a label of a school bus. It doesn't really understand anything about that is really a school bus. But if you show a picture of, for example, so a good example might be some people ferociously arguing on a beach. And an AI might say, that's a picture of some people on a beach and they're having a vacation. Whereas we would look at that and say, okay, here's some people having an argument. We would make assert some internal inferences about the state of mind of those people. We would construct a whole story around that one image. So AIs don't really, and when I talk about this, again, I'm just to sort of contextualize, I'm talking about like deep learning approaches to image recognition. Don't really sort of see beyond the sort of classification part of it. So I guess another thing that so I could say that AIs can't really do the soft stuff. And what I mean by that is that we also have the capability of reasoning without a clearly defined objective. Right? So you can drop us into a situation where we don't really understand exactly what's going on. We can come up with a coherent plan of action to at least get the information that we need to be able to make the decisions that we need. So that's another case in which it can be difficult for AIs to come to grips. Another big one, which I think has been a really hot topic lately, is what's called overfitting. Folks have heard of overfitting as an issue. So the joke here is that an AI walks into a bar, the bartender asks, "What are you having?" and it says, "I'll have what everyone else is having." So the idea is that AIs are only as smart as the training data that they are tested, that they're trained, and then eventually tested. So what this means is that if you train up a system on one particular configuration, and then you face it with a corner case, some sort of slightly out of the normal ballpark range of situation, an AI might fail in very catastrophic and unexpected circumstances, whereas people would tend to sort of figure out, at the very least, oh, this is outside of my circumstances, I'm going to pass this up the chain. So a good example of overfitting is an analysis that someone recently did, where they looked at the recent crop of computer approaches to image recognition, which have been trying to get better and better at recognizing natural images, just pictures of scenes and things. Those algorithms have been getting better and better in terms of their accuracy on the ImageNet competition to a point of like 99%, something like that. It's very impressive. These algorithms have also been getting deeper and deeper, meaning that they've got more and more layers. Some of them now have literally hundreds of layers of processing. But it turns out that if you compare those algorithms that are very good at the ImageNet competition to images that are outside of the ImageNet competition, they're actually doing worse than the algorithms from several years ago. What they're actually learning to do is exploit the regularities in the kinds of images that are chosen for ImageNet, which is not necessarily characteristic of all the images out there in the world. So for example, one of the things that ImageNet pictures of people tend to have is a sort of certain distance from the camera, which means that eyes are sort of within a certain range of pixels within ImageNet, which means those algorithms are bad at people farther away or closer than that sort of distribution of possible images. But another, I mean, this crops up in a lot of other ways. So, for example, we just heard on the car radio on the way over here today that they just found out that algorithms for detecting passerbys or pedestrians in sort of autonomous driving scenarios are 5% worse at detecting people with a darker skin color than people with a lighter skin color, with obviously terrible implications for what that means about public safety in other respects with racial bias. So these little things can crop up in dangerous ways if things get sort of pushed into the public sector prematurely. So, you know, on the one hand, AIs have these limitations, but on the other hand, we as humans also have a sort of tendency agency that's kind of undeserved in many cases. And we do this in many cases on the basis of social cues. I think it was Dan Dennett who was working with Rod Brooks. They were trying to build a sort of childlike robotic platform for interaction, and it had eyes and it had eyebrows. And someone asked him, you know, how are you going to convince people that this thing is smart? And he said, well, when you look at these eyes moving around and following you in the room, the challenge is going to be to convince people that it's not smart. So the mere act that eyes will follow you around the room and the eyebrows might move in some sort of sympathetic fashion can lead people to imbue all kinds of beliefs about the state of mind of that thing, even though it's just a simple tracking algorithm, some maybe pseudo-random fluctuations of the eyebrows. So the sort of flip side to the coin that AIs have these limitations is that in many cases, people might actually be prone to giving them too much trust. And in particular, on these much thornier problems of complex decision-making, where it's even harder to sort of evaluate how well the algorithms are doing. So I think it might have been you, Dan, who was saying this. You know, one of the things we can do, maybe one of the best approaches for using AI is to help facilitate the decision-making rather than to be the entities that are actually making the decisions at this point. Always saying something like that too. So yeah, I guess that's my sort of perspective, is just to sort of keep track of what we think AIs are doing well versus poorly. Now, there's a whole other side of AI apart from the current rush of deep learning, which is what's called GoFi, or good old-fashioned AI. And so there are some folks who are saying that what we really need to do is to marry those two approaches. We need to sort of take some of the lessons from the symbolic versions of artificial intelligence and mix them together with some of the newer insights, and then maybe with this multiple approaches we can come up with more robust solutions.
This is really very insightful, like a very different perspective from the first two speakers, which is really, I hope that it sparks some new ideas and questions. So I think that Dave, you want to take up next, and then we'll
I don't know if we should put the slides up.
Yeah, you can. Yeah, I mean, so how would you?
All right. So what I'm going to do is, I did make some, what the heck, I thought. I'll just hand out these slides. All right, so I guess maybe I ought to start with a bit of a caveat and say, you know, I wouldn't say that I'm not an AI person. I just straight out. But what I have a strong interest in is data analytics and big data, and trying to apply them in the organization that I work in, which is the U.S. Government Accountability Office, which is a federal legislative branch agency. And what we do is we do audits, what we call performance evaluations, various kinds of other assessments, including impact and outcome assessments or evaluations of U.S. executive branch federal government agencies and programs. And our work is who has heard of GAO? Okay. So for some of you who are maybe from other countries, we're a supreme audit institution. So that may clarify a little bit. But so anyway, that's the kind of thing we do. So everything we're doing at GAO, I'm going to call it GAO, is couched within that kind of a framework. We're doing evaluations of government programs and agencies at the request of Congress. So we actually get request letters from Congress to do particular evaluations. And they can be on a huge array of topics. We cover all federal branch agencies except for sort of the intelligence agencies. And so everything from physical infrastructure to justice reform to social services to international affairs to defense, et cetera, et cetera. And we hit on a lot of sort of management and administration topics. So things like fraud is a big one that we do. We do a lot of work on softer kinds of topics like interagency collaboration in a particular program area. So maybe emergency management. So we might look at the whole complex of agencies and institutions and NGOs and private sector and organizations that are working together to for emergency preparedness kinds of purposes. So we do all that kind of thing. Now, where we are in terms of big data and sort of data analytics is kind of in a liminal state right now. So we're butting up against big data problems more and more now. We're trying to introduce an array of data analytics into the agencies to help us do things that are more sophisticated and more useful for our readers, which includes Congress, but also people out in the public. And so that's sort of the challenge we have right now. So I've done a lot of things that are bumping up against analytics, bumping up against big data questions, and this has been a development over time in the agency, moving closer and closer to these kinds of problems and using these kinds of analytics. So I guess that's sort of broadly what we do. My role at GAO is basically this third bullet here. I'm a design methodology and analysis consultant. I'm also an analyst on our projects, which we call jobs. And each project is oriented toward producing a particular report on a particular topic. I work in the Applied Research and Methods Division, which has a whole array of social science and hard science, actually now, types of experts and specialists. So economists, sociologists, accountants, evaluators, and then we have technical hard science specialists, so engineers and chemists and biologists. So very broad unit, but that may give you the idea that we have people who are thinking along these lines in terms of AI. So I'm going to talk a little bit, not too much, about the work that I've done that has to do with data analytics and big data. And so one of the topics I think that actually might set off what I'm talking about in terms of this development, this liminal kind of state that we're in, is network analysis. So social network analysis. So probably 15 years ago, I started trying to introduce the use of social network analysis in the agency. And network analysis, as you may know, is a methodology, is an analytic that certainly has been applied within a big data context, and possibly, used in a predictive analytics context sometimes, and also may have some relevance in AI. So that's sort of the connection that I'm trying to make here. So we started out small with network analysis and Particularly, we started using network analysis around pandemic planning preparedness. So we looked a lot at the plans that were being developed, and we also looked at collaboration practices among mainly federal agencies, but also public, private, and NGO sector. So anyway, over time, we did that kind of thing, and we eventually developed basically an agency-wide kind of network survey and analysis framework that we've used over and over now on our projects and reports. In more recent years now, we've started to branch out beyond that kind of survey-based approach. And now we're moving into things like fraud, using network analysis in the fraud sphere, using network analysis to analyze international trade and development flows and patterns, looking at subcontracting within the federal government, which is a huge topic, as you may know. In the defense area in particular, we're doing a lot of that kind of work. Also on DOE, the Department of Energy, which is huge and does a ton of subcontracting. So we're getting large data sets from these kinds of agencies to do, and we do some network analysis with them. Another one that is kind of a burgeoning area right now is use of network analysis on bibliometric data, and this sort of has a kind of a scope across pretty much all of our projects at the agency. Other things that I've gotten into, and I'm not gonna, I'll maybe say stuff about this later, but text analytics is now becoming something that we're pursuing in this applied research and methods group, and that kind of thing. And I'm not gonna, some of the analytics we're using are web scraping and sort of fuzzy matching and text classification. And these are at varying levels of development at this point in time. So predictive analytics, and we started to use that in the fraud area. So if we have, for example, if we have indicators of potential fraud of particular organizations or people within a particular domain, we can use that to train models for predicting who else within that domain might be potentially fraudulent, somebody you'd want to look at. And then fraud analytics, I'm not going to say, I can say more later about that. But so in terms of key challenges relating to big data and AI, there's a lot of inertia involved in trying to bring an agency like ours into this kind of world, right? And there are ingrained practices. People have been hired with specific skills that are related to the audit and evaluation work we do, but they, by and large, they don't have analytics or big data skills. So you've got to turn this ship in some way, and we've been trying to do that now for the past 4 or 5 years. So it's very, there's an internal learning process trying to bring analytics into the particular schemes that we use, or organizational schemes we use to produce these reports. So bringing in new precedents and practices and learning new tools and standards for conduct and organization within our agency. And then kind of where things are going. Yes, so there's a big movement now to start hiring analytics type people. And we've created something called the Science, Technology, Assessment, and Analytics Division within the agency. So this is a big development within our agency. And one piece of that unit is a data innovation lab. And we're probably going to be hiring a chief data officer for that. So we're definitely moving in that direction, but there's a lot of complexity to making that happen and then applying it within an agency like ours. So I'm going to leave it at that. There may be reason to talk about some of this other stuff.
Great. Thank you so much. David, this is really like, I mean, completes the picture from the government side, like what's happening, at least from in one agency.
Right. I mean, that's one thing. I mean, it's just one agency and every other. Yeah, that's right. There's so many things. Yeah, that's right.
You know, so I think Jane. So I think should we put a mic close to her here, or
we can see how that works.
Yeah.
For sure.
So Jane, should we display your slide? Would that be helpful?
Sure.
Okay. I set the slide. Is Jane's slide?
And while we're getting the slide going, I just want to say thank you all for bearing with the fact that I'm not there in person. I very much wanted to be there in person. But as Asim said, I was sidelined by a sports injury. I'm proof that you don't have to be an NFL player to get a concussion. I got hit in the head with a squash ball, and so I have been sidelined from travel by my doctor. But you know, maybe if I got a lot bigger and stronger, I could be in the NFL. But anyway, so I'll also start with a caveat, which is that I'm not an AI or data analytics person myself. I am an observer of government, and I have looked at city data officers. I've talked to a bunch of state and county data officers. I don't know if you can see me. I'm holding up my IBM publication. Dan did a show and tell of publications, but not mine. So there we go. There's my IBM publication about federal chief data officers. So the observations I have are kind of from the perspective of organizationally, what do I see as the keys to success to getting a big data analytics or AI organizational transformation. You know, before launching into that, I think you all, by virtue of taking a half a day to join this conversation, are already believers in the value, but just in case, let me kind of, before diving into the other stuff, talk about what I see as the value. And in my opinion, we are really at the very beginning stages of understanding just how powerful data can be in government. So first I'll talk about my city of Boston, which I think is one of the great examples of applying data in government. So my city is set to save about $5 million on fuel costs because of smart routing of school buses. And this was a project that wasn't even done by the awesome analytics team in Boston. It was done by a couple of MIT students. And we got a private sector company to donate the prize money, held a hackathon, and came up with a way to save not just $5 million, but also 20,000 pounds of carbon emissions. So proud of my city. The other thing Boston does is save $1 million a year on energy costs simply by using sensors, you know, so Internet of Things, by monitoring temperatures in buildings. They can do things like micro adjustments to fans that have no perceptible change in temperature to the public, but still save, like I said, $1 million a year and $40,000 a year just at my local library, where yes, I do still have to wear a sweater in the summer because it's so well air conditioned. So no appreciable change in what the public expects. At the federal level, there are lots of great examples, but just because opioids are on my mind lately, the HHS Office of Inspector General has a data scientist who used big data technology to lead the investigation that led to a $1 billion takedown of an opioids prescribing fraud from Medicare. So I could actually go on the whole rest of the day talking about the benefits of big data and analytics in government, but But we're supposed to talk about the benefits and challenges. So I want to, if we go to the slide, you can see that I've divided this kind of into two pieces. One is the challenge of getting a data organization up and running in government. And then the other side of the slide is about kind of, if you think of it as launching on the left, on the right, it's about the continuous sailing forward. Pretty much the most critical thing is executive buy-in, right? As I study successful and less successful data analytics efforts in government, what I notice is that when you have a mayor, a county exec, a governor, a cabinet secretary who really pays attention and who is focused on data, that's where all the senior staff know that they have to listen to the data officer and have to participate, contribute data. So executive buy-in is absolutely critical. And having a clear mission often stems from the chief executive making it a priority. And sometimes that's because they've issued an executive order or a memo or a policy directive, but that they have said, this is what analytics is going to do. And I think it's important to write it down and to communicate it, because otherwise, as data officers tell me, they go to meet with someone and want to talk about, you know, predictive analytics or artificial intelligence or Internet of Things. And when they go to meet with someone, instead they're asked to fix the printer, right? So the idea of separating technology operations and, you know, what's going on with the servers from the power of data and analytics is something that can be called out in the mission statement. And then I think another critical piece of the launch is figuring out the right organizational structure. And I think that there are as many right answers to the question as there are types of existing organizations. You know, some are better off centralized versus decentralized. And I think that, again, going to my example of the City of Boston uses a hybrid of the centralized and decentralized. We've got a couple dozen super staff at the citywide analytics unit, but then a number of entities, the Boston Public Schools, the police department, have their own analytics teams, and the central staff doesn't serve every agency. They serve the ones that don't have their own analytics staff. So, for example, the fire department gets their services from the central analytics team. So the other thing about launch is to create a team, and it's important to have a diverse team because you want to have different skills. Those who code are necessary, but there's nothing to code unless you figure out what's the business problem that you're solving. And the most critical thing I think, in any research endeavor, whether it's big data, analytics, AI, you know, or kind of social science research, I think the most important thing is clearly defining your research question. And to do that, you really need business process analysts who can get into the customer business problem. So, you know, I think for launch, those are the keys to success that I would point to. In terms of keeping an analytics program on a successful track in government, I think create a strategy, document the strategy, share the strategy so that as you're going, people know what they can expect. And also it helps the team. You know, it doesn't just help externally to customers, it helps the team know what they're about and be able to connect back to purpose. And then I think some early wins can be very important in getting legitimacy, getting visibility, getting momentum for an analytics program. I've been working with the city of Chicago for, I don't know, 4 or 5 years. And when they first started their analytics program, the then CIO went out and met with every single agency and explained, hey, this is what we can do with big data analytics. This is how we can help improve your operations. And it took about a year between the kind of almost marketing of the effort and the first round of analytics projects that were successful. And once mid-level and senior managers in government started to see, oh, I could get a 20% improvement by working with these data people. I could be more efficient. I could, you know, one example, if any of you have been to Chicago, you've probably been to a restaurant, and most cities inspect restaurants to make sure that there aren't unsafe conditions that can make us sick. Well, no surprise, most cities don't have enough restaurant inspectors. Chicago worked with the analytics team to get a predictive model, 32 different variables, including weather and, you know, calls for service for disturbance on the 311 line, stray animal calls, all kinds of different variables factored in. And they're now able to get to the most high-risk cases 7 days sooner. So if you went to Chicago, ate at a restaurant, and didn't get sick, you can thank analytics. You know, getting some positive press really helped get momentum, helped build some credibility for the program, and switched from a place of having to go out and beat the bushes to market the program to a place where there's quite a bit of demand for analytics and great deal of buy-in. So what happens once you've got some momentum, you've got to make sure to maintain credibility by doing things like assuring data privacy and also assuring that algorithms are not built on data that has bias. That's something where there is not yet a good housekeeping seal of approval for public sector analytics projects for ethics of algorithms. I was part of a team that developed a toolkit. We put it out last fall in beta form. If you know anyone who is doing a public sector analytics project and wants to use this toolkit, please contact me so we can get you using the toolkit and giving feedback, because it's still in beta form. Anyway, so those are some thoughts on the keys to success. Yeah, that's it.
Dean, thank you so much.
Sure.
Thank you.
You're welcome. Oh gosh, now it's echoing. I hope I didn't echo when I was talking.
Right.
No, perfect.
It was great.
I think it's just.
We were able to also relate on the speaker here, so that was good. Okay, so I think I just wanted to open up before we go to the next round of questions. The panel, like based on the responses so far and what you've heard, do you have any questions for the panel? Please.
This is more for Rob and Brad. I was talking a little bit about what to do with big data, and Brad was talking about creating cognitive models. And there's a new paper out by some folks at Princeton. It's got Agrawal, Peterson, and Griffiths, and they take maybe familiar with the moral machine data. They do something I think is really interesting, which they run a kind of machine learning model on a really large data settings, millions and millions and millions of observations. And they see, they use that to fit the data to see how explanatory it is of people's decisions in these moral dilemmas. And then what they do is they compare it to a simpler model, like a basic, like a regression or utility maximization model that has just some basic variables in it. And then what they do is they take the residuals from the regression model and look and see compared to the predictions from the machine learning model when there is like extreme variation based on the residuals, which I think is really interesting. And then they were able to figure out which other variables should be included in their regression model to get closer to the accuracy of the machine learning model. And so I thought this was a really interesting example of looking at the micro data, this really large administrative, not administrative data, but it's individual micro level decision data. And then having some more transparent models with like regression models, and they were able to get the accuracy really close over once you use over 100,000 observations or something. So I was curious, thinking about the cognitive models and thinking about uses of data, other ideas maybe the two of you or other people on the panel had about creative ways for using some of this micro level data that we're getting to help address some of the ethics issues that Paul was bringing up. And if you've seen other examples of this or other creative ways of trying to merge models that we have a better sense of what the variables are and their strengths with some of the machine learning, because they can be kind of black box style. Just any other examples of stuff like that, or any thoughts you might have about, because I'm really interested about how to address the ethics question and dealing with some of the black box issues versus kind of traditional utility maximization models.
I'll start with the general observation that I've been around the neural network community long enough to regression models can do a lot of the work of deep learning models, just because one way to think about a neural network, which of course a deep learning model is just many interior layers, because a typical squashing function in a neural network has this kind of sigmoidal property. A neural network with one layer is just a cascaded logistic regression. You're basically taking the regression, doing a logistic regression on the input to the interior layer, then interior layer to the next. So basically, it's two logistic regressions. So all a deep learning network is 200 in essence recursively structured regression. So then there are going to be then ways to represent that in some more compact form. I guess it's unsurprising to say some of those results, but that's not what you're getting to. I think there's always been this debate in AI from the first and second generation AI was mostly top-down AI. We have today is mostly bottom-up AI. Bottom-up AI is much more available to eat these microdata, to digest microdata. But then always the debate was how far can you get there with more top-down AI? And so my sense is that these aggregate regression models are much more like, you think people could articulate a rule for why they did what they did. Although it's famous in cognitive science, but if you ask someone why they did what they did, they can't really say that. But whereas the neural networks, the trouble is they're deep learning models, they're so black box that you're very, I think we're very reluctant, at least policymakers are very reluctant to actually trust them to do decision making, but they're only going to use it as a decision support tool. Because you don't know what the guts of it are doing, right? So there's always this tension between kind of intelligibility versus fecundity or versus kind of accuracy. And that's always going to be a trade-off, like the class of tools that we're doing these days.
I think it's touching on that issue of sort of inscrutability of the deep learning approach. So people are, on the one hand, afraid to trust these approaches because of the black box, and we don't really know what's going on. But on the other hand, we also sort of have no problem giving that agency to people, even though people's brains are similarly black boxes. So there's this sort of asymmetry in what we sort of think of as, I guess we're comfortable with thinking of another person as having agency, even though their brain is just as opaque to us, or maybe it's more opaque than the layers of deep learning network.
The person accountable, though, right?
Right. Well, exactly. Right. There's other things. There are other factors that play into it. But I think that it's not just about the sort of inscrutability. You're right. It's accountability. It's sort of the key feature. One of the things that I think is key to developing good approaches to making, for example, decisions in a moral or ethically constrained space is building a representation of the internal dynamics of how that space exists. And my assumption is that, without being familiar with this particular, with the data set or the modeling approach in this case, is that the representation would probably not be very robust yet at this point, in large part because we don't, even deep learning approach, which has been trained on all of these individual micro decisions, is still lacking sort of common sense aspects that a human brain has been trained up with at that point in time, which serves as a sort of fallback canvas on which to predict reject a lot of these problems that are being presented to it. So even if a person has never had to grapple with, for example, what do I do in the case of cancer before in life, they've still got a long time to understand what disease is. I've seen and heard about it. So there's a lot of rich and varied ways in which this moral landscape intersects with the experience that a human adult has had after 20 years of learning all this stuff. And I think until we learn how to build a representation space in AI architecture in some way that has that rich history and those complex dynamics. I know that this is unsatisfying because I'm just saying there's some magic there that we haven't captured yet, but I think that that's still a part of it. And so, I mean, some of that is simply, just time that a person has, 20 years of experience. But then on the other hand, someone can say, yeah, but with these new accelerated AIs, we can give an AI 1,000 years of simulated time, in 20 minutes. That's a little bit of exaggeration, but the point is, that's not really the argument anymore. It's not just about the sort of sheer amount of data that's being processed by this network to sort of build that representational space, but there's something also about the way that the human brain represents the information that might lead to certain approaches or representations that are qualitatively different than what we can still get out of these essentially complex regression systems. And I think a large part of it is just sort of the training aspect, that the training of these approaches is sort of, you're training the algorithm to predict the correct decision, which was the one that the person made in that context. Whereas we're not being trained according to that same criteria of correctness. It's not really clear exactly what the objective function of the human mind is. It changes a lot from situation to situation.
Can I pick up on that? I think that the example you're describing, Justin, is interesting because you're getting the outliers in the basic regression. And from a training perspective, it's not necessarily that you have to train the AI algorithm to deal with every outlier. You could train the AI algorithm to kick it over to a person, right? We can't deal with that particular way. If the AI algorithm takes from the outliers from the initial regression in the way you described it and says, this is too hard for me to compute for the reasons you suggested, we just aren't able to do AI well that way, then the cases where people challenge because there's an ethical issue or an issue of bias is often based on their unique circumstances as an individual. And in that case, the AI potentially could, in terms of augmenting human decision-making and service provision, can know, all right, in this case, I'm just not going to try. I'm gonna stop and kick it over to the customer service manager or the service provider in the government or the medical provider. And I think it's interesting to think about a training perspective as to train the AI to know when not to go too far. And your example struck me in that.
Just to follow up.
So,
go ahead.
I want to just jump in there because Dan raised the issue of humans. The AI kicks it to a human, but I want to, and also I think Brad used the word accountability. I have yet to see, other than in New York City, an executive. Actually, in New York City, it was the city council, not the mayor. But what I want to see is where a cabinet secretary, a governor, a mayor, a county exec, a department head says, I'm worried about this problem and I want someone to study it. And other than the handful of city chief data officers who have been actively participating in this conversation, I don't see policy people stepping up to say, we need somebody who's in charge of figuring this out. And I don't know when that's going to happen, but anyway, that's one thing that I think we need to agitate toward.
At the federal level, I think there are many examples of this, where it's a very concrete one, not too far from here. Over at HHS, I mean, there is turns out a medical doctor who's in charge of public health for the country, and he has sitting on his shelf a model that basically says, if we wake up tomorrow and there is a very bad outbreak of H1N1 in San Francisco, newly arrived from the Pacific, does he shut down interstate trucking, yes or no? And he's got that model on the shelf because 10 years ago he asked for it to be built because he wanted to study the problem, and it's a very detailed model with all kinds of microscopic variables. And of course, he or she, I don't remember who it is right now, is a medical doctor with a lot of experience on working on epidemiology from a scientific point of view. So this is one example of where, sitting in this town, there are people who are ready to go on a policy basis because they asked the question which you mentioned. They already asked that 4 or 5 years.
Well, I just wanted to pick up on that sort of augmented decision-making idea that several people have mentioned, and it seems like finding that sweet spot between is important. But I wanted to pick up, a couple of them mentioned that we can free ourselves up from low-value work, and you talked about, Dan, how maybe the AI can know when it's run into its limits and pass it back to the individual decision maker who has more capacity to do that. But is there a value in low-value work? That is, do people who are decision makers need to, in some sense, need to be messing around with the Excel sheet themselves, and seeing how different things connect? I mean, in my own role is figuring out how to allocate graduate funding. I only run up against the reality of budget limitations and the way that an administrator thinks, because I have to start to think like an administrator, because I have to start to play with those numbers myself. As imperfect as I am at doing it, as much of a waste of time it is, I gain an understanding of what actually we're dealing with. And now I know just a little bit more about what it means to be making decisions in this position I've been given, because I'm making these relatively easy decisions, and I think now I can make a little more sophisticated decisions because of that. But I had to do all that low-value work to get there, in a sense. So if you're taking that away from me and just bringing me in later, I might not appreciate all the different, I might not have gone through my own human learning process to be able to make the moral judgments that I need to make. So I just want to add that or question that, how is that part of the human learning through low-value work might also be part of the augmented partnership model.
So I think that's a really interesting observation. And it's almost the AI equivalent of, kids don't do long division on paper anymore because they all use calculators. So they don't know how to add up a row of numbers. I think there's a difference between learning that goes on so you know how something works and sort of the ability to practice it quickly on the job. So you don't have to reconstruct a regression by basically doing it manually, which is how I learned to do it, learning how to move up the graph. But you have to know how that works. So it's almost like we need to make sure that we're training basic science and math in sort of how people use AI. I don't know that we want to require them to build the regression map on the graph each time, but they ought to know those skills. And that's part of, I think, the challenge of when we think about 21st century workforce skills. It's not just about how to use the fancy algorithm. It's about knowing how that's built and being able to use it effectively.
Right, and this is actually something I'm very concerned about in the workforce. You take a city like San Francisco with one data scientist at the city level for, I don't know, maybe 5,000 city employees. In Chicago, there's one data scientist. In Boston, we have more. But if you think about the, 0.1%, some very, very small percentage of government workforce are data scientists, how do we bring up the data literacy of not 100% of the workers, but at least mid-level and senior managers who are making decisions? And my way of thinking about this is that I don't want every mid and senior manager in government to be able to create their own algorithms, but I want them to be smart enough about data science, AI, to be able to ask tough questions. So my analogy is this. I think the management and executive track need to have the skills of a general contractor, right? A general contractor who builds my house doesn't do the electrical wiring and doesn't do the plumbing, but they know enough to make sure that that stuff is done right. And that's the future vision I have for leaders in government, is that they can be the general contractors of data and analytics, where they know it's important, they bring it to the table, and they can do the quality control.
going back to Paul's point, I think that's a really interesting perspective. And I think about a general contractor. I really like that analogy. But the question then is, how do they get that expertise? And I think in many cases it's because they serve their time, in the trenches, so to speak, right? And so if let's imagine that this gets to your sustainability point, Jane, very nicely, I think, which is that, imagine that we implement all these new changes. The first phase of that might actually seem very successful because the managers on the top end, there's people who sort of work through that process, and so they're good at still making those decisions. But then sort of the turnover, the next phase, those people are still at that same level and they're still sitting on top of a whole bunch of sort of analytics approaches, but they no longer have that apprenticeship approach, and so they may now lack the sort of intuition.
Exactly, and that's why my focus is really on mid-level managers, because they're more likely to stay in government, whereas the appointed people, they're going to leave, right? I was appointed, I left. It was the people one notch below me who stayed and had the power to continue things.
Jane, the other thing your analogy points out is there's a difference between what I'll call the AI users, people who are using data and sort of benefiting from what I'll call the AI builders. People, the experts that are building the algorithms have to know the basics as to how you get there.
Yeah.
You don't have to know how to. This is not a perfect analogy, but you don't have to know how to build a car to drive a car, but you still have to go through standards and learning and get educated how to drive safely, and it's just a different set of skills in those two scenarios.
Please.
Sorry to build on that. It's the question of how do you do that in a workforce where we're always on the go, and we know now a lot don't want to be doing professional development activities, and they don't take it seriously, and so how do we find that sweet spot of making them more illiterate about these things without them like, oh, another professional development activity, I don't really want to do this. I'm not really paying attention, and mine's elsewhere. How do we bridge that gap to teach those mid-level managers without kind of that resistance?
One thing from my own organization, I'd say is we are hiring people with analytics expertise, and the people who are kind of, I guess, legacy, but who predominate in the organization are basically policy analysts with primarily public administration and policy analysis backgrounds. And what I think is happening is there's a incongruence in the way those two sides think about the world. And so part of bringing those two together is, yes, okay, let's get the policy analysts more knowledgeable about analytics. But it also is for the analytics people to articulate better what they can bring to the table in terms of answering specific questions. So we're talking here about valuation questions, audit questions, things like that. So it's necessary for both sides to sort of come together. One way to kind of ameliorate that is to have people who can, to bring people in, or have people who can interpretively and conceptually translate from one side to the other. And so, for example, that's a role that I've been trying to play. So I'm a social scientist, I'm a sociologist with both a lot of qualitative research experience and quantitative research experience. I did my research, my dissertation research on economic and social political transition w Polsce we wcześniejszych lat 90. Byłem w Łodzi przez 1,5 roku. So I did my dissertation on economic and political transition in Poland in the 1990s in Łódź. He's from Łódź. Anyway, so that's my background, and So I've been working towards trying to fill that kind of role in my organization.
If I could mention one other thing, which I would maybe chalk up as kind of a risk factor, and this comes from a little bit of experience of looking through another transition that happened about 15 years ago. So about 15 years ago, the DoD transitioned from having a lot of models that were kind of a arrogant nature that they were using for very restrictive functions, and they moved to think about combat models. And so combat models were models in which you could have every individual actor, every individual soldier represented, a weapon represented, et cetera. And so it was a big move when enough computing power became available, like somewhere around in the early aughts. When and so you basically have models of army engagements or military engagements where you have basically computationally intensive representations for things like line of sight, and it's almost video game quality stuff. But the quick background is that at that time, and before there were standards created, there were a lot of contractors. And these are kind of like the DoD contractor community I'm thinking about here mostly. Basically, were selling a lot of snake oil. And they were basically, because there were no standards, they were promising things that were, to be honest, they were promising more than they could actually deliver. And then what the comical example is, so as one time it called in to do an evaluation of these things, and the general who was looking at the vendor's product also, looking at some particular example engagement, said, to what extent are these artificial soldiers in the model displaying heroism? And of course, the proper answer would have been, well, they aren't doing that at all, because that's not part of what no one knows what the hell that means anyway, right? But the reaction from the contractor was, well, they don't really have that, but kind of. And the general says, well, come back to me when you've got that programmed in. And sure enough, they came back about a month later with they programmed in, right? And so that's how it's now, what I see right now today in the data science world is the rough analogy that says that there are a lot of vendors out there selling things that are going to solve all problems, right? They're going to do it's the snake oil of the current environment. And whether your problem is you got to compute an eigenvalue, or whether you have to compute a simple average, and their generic software can solve every problem. Probably do it on the cloud. Probably do it faster than real time. I'll have all the jargon, right? And it seems to me that unfortunately, right at this present moment, we don't have any standards, and those have to evolve, and that's going to take a decade. And so in the process, at least for the federal customers, for the federal people involved with the federal work, there seems to be this higher risk associated with buying tools that are not really the right ones for the problem you need to solve.
It's a good point.
Yeah, that's an issue we have right now, is trying to figure out which tools to bring in. A big one.
I hate to interrupt, but I think let's continue this conversation after the coffee break. We've been sitting here for a couple of hours, but I think there are a lot of more questions that we have, and I'm sure audience would have questions too. So let's take about 15 minutes break, and there's coffee and some water, etc. at the back, and we can recongregate with the questions. Jane, so you can have some coffee break as well.
Excellent, thank you. All right.
So just 15 minutes break. Some really interesting questions.
So it makes sense.
I think so. That's why I wasn't there.
Okay.
Because we were not going to do that.
Right? Yeah.
First Thursday, we have to. Yeah. Good. I'm sorry, I blanked from him. When did the slide?
That they got to do.
So they have a simulation. They have a simulation, and I don't exactly know how they are in the presence, but either go left or go right.
Yeah.
It's like a trolley.
It's still a problem.
Well, yeah, I mean, it's the bringing these different perspectives.
But again, their theory of morality is that the average.
But I think part of what they're trying to do is identify inconsistencies, like a rational approach.
I really get
so. One of the things that they find is people are more willing to.
I mean, some of these issues we can talk about
what is it?
some of that suspicion. And I you guys are looking at that.
Yeah, we're actually, the last session we're doing with
We're not going to push all that work. If you have something going overboard, I'm not going to stop us.
Yeah, they just show some of those types of things in that UI.
Is actually working on a government-focused application with
You say women more often than
address
men.
bias
Say skinnier people
in
more
the
often.
shaping of the
But what do we
algorithm.
want? Do we want?
Because most engineers
We're
are going
gonna give
to
that
sort of think about that as
part
their
of
build.
this.
It's like we have cybersecurity.
Do we want
If you
them
don't build
to
security into the application, you
do
really
what the
know
average
that's
human would
right.
do, or do we want them?
So we're trying to think about how do you
You know,
actually
do we want to be
build
able to say, well, yeah, I
mitigation
would,
bias. I thought Justin's example.
as a driver of the car, that's what I would do. But as a citizen in the world.
And you brought food, right?
Yeah,
So funny story. So the whole conference is at the Mayflower.
Oh,
So of course I didn't scroll down your notes. I just went over to the Mayflower.
I know, and I was arguing with them too. So
I think the only thing about
where it's
from
just like
the task level.
Yeah, I get it. I got there early enough that
Should.
but I saw Bill Shields, right? They
Right.
sort of
So
asked
a couple
the
papers
executive
under
director, and I
review.
said, I gotta go.
Got it.
I'm saying I should
No, it's my fault. It's my fault.
So my argument essentially is that we should compare it to human performance rather than some idealized performance on the task. And then my thought about a criteria, I'm trying to think of like, okay, what criteria should we use given that government has all these competing effectiveness, efficiency, equity, democracy, accountability. And it's kind of simple, but I've been thinking like maybe we should just start with things that we know people are bad at. So like, all the stuff that Kahneman and Tversky is cognitive biases, and then he in his Thinking Fast and Slow book highlights there's all kinds of expert judgments. And you just have a simple additive rule of you're going to measure these 4 things and you come together. We know outcomes are better. And so what sparked this in my head was I was at the Minnebrook conference back in August. Maxwell, and I was having a conversation with a judge who's a former federal judge, and I was talking about how part of one of the things that machine learning can do is identify all the variables, for example, that might predict recidivism, and that you might want to use the predictions of the models for recidivism over and above judges. His comment was, those models will never be as good as I was. I can take in personal cases when they can't. And my response to him was, I was polite. My response is, we know you're bad.
So why did you leave? And we know it's right that you make a different decision
After lunch, exactly. You're punishing right before lunch. So what I've been thinking about is high consequence tasks, like the judge decides. We know that the data that those models trained on are biased. We know that the data is however, we know that the reason that the data is that way is because all the judges have been making those decisions that are more punishing for bias. So I wonder what types of situations, right, even though we know the algorithm might be biased, is it less biased than, say, a judge?
We have been structural for a long time, and I was as the sure I was only
So from an ethics standpoint, like, I would almost make the
argument
now, based on augmented versus completely off the move, and there's a lot of ways to think about it. Right now, we might have an ethical obligation to society to take that away from judges, take that discretion away from them.
As you know,
Or at least it's like a default.
So
So
our programs by, say, people grew up in the same privileged education.
Yeah.
yeah, but there's all sorts of nuance. So right? You could make it a model and then measure the judge's performance over time relative to. There's like a lot of ways around it.
Or there's an augment. You can train judges to.
But the big one we have now is
You can imagine
you do have a better augment. You're able to access all the census data, which is
You're not
virus
seeing
data. That's what looking at the firm data.
You don't have.
So it's roughly 6 million firms and 100, and they have about 120 million. So that's basically the US private sector. And so,
But that's
so we have those data. So that's we have a.
AWS is the house for that or not?
That's actually. So too, we do so even though census houses these data, instead of us going into their data repository and just touch the data, in which case then they have
Also how much you're going to trust.
to clearance on that data.
You have to get like an API
That's a problem.
That's already approved.
for. Oh, okay.
But what we have to do is everything that comes out of there has to be.
Interesting question.
in which they then.
What is your question? What is it?
We found that it works better.
The political piece. But from just a performance standpoint, it seems like a pretty.
Some special.
We know the types of
Very
expert
fine
decisions.
grained
Experts. We know they do a better job. They don't have any feedback. This is an open situation, right?
They call it
Go around that.
We're one of the
so basically
things I've been thinking about in my own research is
where you have
which tasks can we automate? Not like at the
characterize
position
all
of
American
tasks
firms
within
according to
Right.
sizes.
Right.
So which ones can we automate, but also which ones should be automated? What should be the criteria for deciding
By conventional
tasks?
These data cannot be used to look at the firm
One of
financials.
the examples, Paul and I
Congress is too concerned that would give away the kind of jewels of the companies. But once again,
decisions about
only aggregate data enough.
and so we know that judges are more harsh for lunch. We know that they suffer
Yeah,
from
there's that.
cognitive biases. We know they
But how does that,
suffer
like,
from
so
racial
would
biases,
exclude, like,
right?
content?
We know systematically that judges watch
But
decisions
but
about
yeah, well,
so do we have a ethical obligation as like public servants
Well, not just Uber,
to automate
like
that
my own
task,
company.
or at least to have it augmented, or
Yeah,
for the judge to have to take
so I have your company.
into consideration what the data says about this particular person.
The company.
Because we know it's
Yeah,
simple,
I've got
we know it's
that.
simple
I've got
added
that.
4 factors about the
I
person that
every company.
on average will do better
It
job.
has that level of data.
They
So anyway, yeah, so this contract
So, and
company
that-
maybe
that's
gives
the-
employees Exxon.
You know,
I have Exxon and I have a contract. I don't know.
AI, good or bad, it's compared to
But humans,
It's like self-driving cars may be a lot safer.
Which all of ours are.
Oh, is that
But the one
I
accident
mean,
you
we
hear
try,
about is gonna
we
get a
try to
lot
hire,
even though you
but the
could
going rate for
maybe
people that use
disprove
the
that
code that we have.
the world will be a lot safer if there were more
So we have a
cars.
contractor.
So-
So we would not have, you know, we only have basically, we only have data on this. Those employees who are paying American taxes.
Projecting.
That's
I mean, we know what that
Yeah,
is.
no, I know.
But it is comprehensive, and so.
Because
Yeah, I
we
know.
have choice.
And then, and so that's what happened.
Where's the liability?
You go on those accounts and say, can we build them up?
the other piece I
And we
think
say
is
that,
like,
so what we find is all
my
these
same
data are,
issue
we
was
find at the level of 6 million
compare it
firms,
to
there are
humans, you don't compare it to absolute standard. But then, how do you compare it? Right? You have a distribution, say judges, you have a distribution of judges, right? The world's best judges, the world's cheapest judges, right? So when AI can do better than the world's cheapest judges and the next, at what point do we say like, we want to get rid of them 40% of judges because we know they're racist, we know they are.
Or you at least give them a framework to say, you know, 95% confidence, this is the range you should be looking. It's almost like
So
automatic sense.
this is almost the entire private sector.
It's one of
Is
our
actually in
reports
some kind of,
from last
blue
year.
purple area. And those red areas in the map, which are rural, that's where all the farms are that don't have no employees.
In prison. So, how many prisons
so
actually use AI?
Of the, yes, so of the $30 trillion
Patterns of treatment,
about 29 trillion of the 30 is actually
was released
from that.
behavior, and then recidivism. So it's
Right.
sort of
So there, so
looked at, you know,
we have all those
how
data
it's
too.
affected
We have data on location.
and then they adjust it there.
The issue, the second where you're doing code for us, we had a
favor the ones that merit.
we know we're trying to basically instantiate populations of 120 million agents, software agents.
That gets the point
They're
that
basically micro
activities, they're useful in some
which
sense,
rules would they
but not enough.
follow in order to perform 6 million
Get into
firms
the minutes.
with the right age structure, with the right of those 6 million firms, one firm has 1 million employees, Walmart.
Sort of know which tasks, it's not really trying to think about like what should the standards of criteria be, which tasks we should automate, which ones we should keep.
All of them So what we don't do, we don't do any kind of separate, like self-normal counters. We don't do any really counters on all those data.
Yeah. And I think
Those
it's
data are not,
interesting
I'm
to
trying to
think about
explain
how
those
it's
with
breakdown.
the other variables.
Some of
Those
us
are the
need
targets
very detailed
of
feedback
a behavioral model.
you know, job by
So
job.
so that, now that model,
Breakdown
in
what it
order to
is.
realize 120 million agents,
And, you know,
we
This is
basically
what I'm doing in the fall when I have some students with Steve Ryan in Texas, trying to do an in-depth task analysis. Everything that the city does, start with job descriptions and talk with people, then go do a topological assessment, see which of those types can be automated.
Yeah, exactly right. Yeah.
And then try to come up with some criteria.
Exactly.
Okay, which one should be automated? Which one should be? For example, like when I'm thinking about things, there's a lot.
Determined by
Things that
machine learning.
there are about efficiency of
We're working on a small city.
Yeah, but
Yeah, so it's a unit
A
where
lot of core logic is
control not that much government. But
Initially,
there's
we're
not
not buying from them very heavily. They created some
I'm
good
really
stuff.
yeah, yeah. I'm really
Maybe
excited.
an aspect.
Yeah, yeah.
It's
That's
not created for us.
my head about this criteria.
They shut it down.
We were trying
Yeah,
to
so
talk
they
about
gave us all.
complexity and consequences of the decision. And so, anyways, that's why the whole conversation about not jobs, I don't think that's the appropriate.
And they had a longitudinally, tasks. They were able to provide
And then
us.
moving towards higher value tasks, how valuable are some of the low value tasks? Then which things do we just want to keep? So I started an RSF future program where we're looking at create robotics and AI groups.
Not the county tax
robots that can program firefighters.
We thought
And
the actual
since,
sales.
and since when they would help,
Yeah.
when there's risk.
Sales, of course, are part of
So one of the things I want to find out from firefighters
I left
is
my house for
which things are they okay with
I can't sell it for 3 days.
to a robot, which things are cool firefighter activities.
But
We care about the one firefighter being motivated, we,
I don't know about other things. These guys can be happy. There's actually some dirty guy over here. Put us all together. And he's got all of Baltimore, Washington. Then we said, well,
Yeah, 'cause it wasn't on the main
holding our breath. He said, like, he said $100,000. We get the money. Yeah, it'll take you a day or two to put that together. So you probably I can charge that car So we get basically the entire
So now you can enter the actual.
Yeah.
And even the history.
The history.
It's not a use case.
Exactly.
Another
How does somebody lower the price?
Exactly.
Then you get stuff like that.
There's a lot of
When the prices are running out, then the list can price for this much. They would probably sell for a little bit more. So this is a bit up, right? And then when everything collapsed, it was exactly
Yeah.
it's handheld, like, go on and
so that's
connected to a lot of
very successful. But they took it out of
They just know, like,
I didn't have so much more data than I used to have.
trainer rotation sort of total signs.
So it's not
That's what
I can do in my office.
And you say, well, maybe
Well, on that side, I think we should talk about
so it's sort of forcing you to think.
the educational limitations. I mean, you're in an area
and it's you know, there's so much more to consider than efficiency and effectiveness in the position right now.
about.
The other one I thought about too, yeah, the other one I thought about is US Postal.
Yeah, that's right. All a little bit of coding.
So maybe eventually we can replace US Postal workers with drones that deliver mail. Do we really want to? Right? We want to take, we want to like lose postal service, right?
Arizona's already.
But it's another question like as, you know, there's something about the interaction with your postal worker historically. Exactly, yes. So like, is that an area where we should try to protect them, even though
The department there.
Amazon
Oh,
and
you
drones?
mean because it's
We're
helpful.
all in
You
our
can
own
see it.
worlds and we're expected to.
Yeah, or something, you know, somewhere you like that, like, or just for cultural reasons, it's just such a big cultural identity. It's like, when we can replace firefighters, if we can, should we? Or should that be?
There's
No,
always
it's
just
You're not really, there's all this pressure to know all of that.
Nope. For better and worse.
And also, like, do I need to know? Sure, you'd be great, you know, but,
You ever like to know too?
yeah, exactly.
The reason with the government services, you
There's trade-offs, right?
don't have to be so rigid. You can't.
Even city government, they're not doing something because they're doing it.
Exactly.
And I'm not saying that that's the right option.
And that was long after
refrigerators.
They're also watching
example of the CRD.
And that's the other way to think about about.
We used to basically teach everybody
Not what things
how to
we want to automate.
microscopic coding.
That's part of it.
Like
It's actually what do we want models for this? You know, about sensational experience.
And they put it together.
And you know now you're seeing
Yeah.
so it's not like you're seeing like
Here's the model of X.
you
You just
just
change
change
it, use the same code, but not kind of data from a different
So,
system.
yeah, what's the value
And now it still works. You can exercise and use it.
It's kind of like ice washing.
So do you have a legislation title then? You actually, that's how you work.
So the next
Yeah,
time
yeah.
you're
So-
gonna use, you know,
I have many hats. I have a career before I did that. So I was a nonprofit executive, so I'm passionate about nonprofit financial management. So I did some research in that stuff, but it's only because I want to help people who are going into nonprofit.
specify what picture you need.
But intellectually,
And I got out.
I'm interested in the way that federal agencies should
And I think a lot of times,
consider national
To
regimes.
allow small scale farmers.
So in that process of
you're on
implementing policy, which was more actually government,
You mean like if there's a- you mean
non-regulatory.
at a local population, like one farm can't supply.
Agencies decide what to emphasize.
Right, you have multiple farms. And
They
multiple
enjoy possible
districts.
benefits.
They have that farmers market.
Right.
They actually have an impact on
But if you just- you can do the farmers market all.
I get it.
range of things. What is the value of preserving
You know, and I've got extra carrots this year.
that's a high level value discussion. It's not just.
I like the idea of an
does it
online
produce enough money?
You would use
Well,
AI.
there's all these bigger questions on national security.
You know, in the winter,
And so, I'm just.
you accidents or demographically, there's a youth population.
Can that be, can that be a data transaction?
Less fewer parents and children.
Straight up up.
Yeah, so I have a data set, it's a survey, it's small and it's tentative, 506. People who participate in the program, in a voluntary way, so.
So how-
we're not
yeah,
forced
we,
to change things.
Right.
But why did you adopt
you know what, these days,
practices
I
that
know
were
it's
different?
right.
When you have to, you know, and what are the ramifications like more widely for the values that we have in society, which I never actually
Yeah,
this
that could
topic,
be
because I think what AI does is, well, it should be called AR, actually, it's artificial rationality. It's not, it's not there. I mean, clearly, I mean, that's what questions are rationality, intelligence, anyway. You concretize the next one, and I think that could be a challenge for,
And it could be
if
fun if there
it's
was more
used in
things to see that
government.
way.
I don't, people will use it as.
Driving through Florida,
We'll make decisions that's reasonable, we're not gonna use it. Yeah, but, I do think that it causes you to concretize it in a way that you don't have to as much. And once it's concretized, then you can shift it to something new.
Right.
I don't know. You know,
Have you ever read much of the work of this woman? She passed away recently. Lynn Armstrong.
I do.
yeah, absolutely.
Some of this, what you're describing, a little bit sounds like
Yeah.
she did like, in essence, she has a lot of volunteer. She analyzed scientifically how these volunteer organizations came to do it. I mean, even though many individuals in the organization were not kind of prohibited from doing it in their self-interest.
Yeah, well, I mean, first is kind of the answer to trying to.
Yeah, exactly.
No, we're actually not stuck.
That's right.
People are capable of self-governance if given the rights.
As long as they're not economies.
Just
We're always hoping to win it. But yeah, I just know, I got to know her a little bit before she passed away.
Did you?
And she did try to get a bunch of data from a lot of those. It's just like, she said like wood gatherers in Japan,
Right.
forests in Nepal, and stuff like that.
I mean, you really have to go on
Yeah, exactly,
gathering
yes.
expeditions, which, you know, we're also expected to do. Like for us, using secondary data is considered tough. You know, you better do something like your own data, which just ups the ante. It's like, okay, how many skill sets do you want people to have, and how useful is that? I mean, I'm getting my PhD, so I'm in academia, but for those people who are getting their master's degrees, I really want to be.
Good to stop and look at it or listen to it or see it or whatever.
So we degree say public policy on that?
Public affairs.
Oh,
Yeah, technically it's a school of public affairs. But it's public administration.
That's what my degree says too.
Really?
Yeah. Don't call it.
Really?
We mentioned many times this guy Herbert Simon. He had a Nobel Prize in economics, and he was a Turing Medal winner from the Computing Machinery Association. His degree was actually with public administration.
Yeah, I know, and read all of his old writings, and like there's nothing new under the sun.
Right.
Really, many people like him really keyed in on all the important stuff early on, and now we're all just like filling in these little gaps, right?
It feels like that
Isn't
sometimes.
that like that in economics too?
Yeah, a little bit. It's a good degree to have, but it's so general. You do a lot with it. So it's kind of you're a journalist.
Yeah.
Specialist.
Right, well, yeah, although I think there again, you're expected to be both, which is a broad view of public administration and governance, right? And then this like really good expertise, whatever micro little.
Yeah, true enough.
So when were you
I was working in the 90s and the early part of the aughts. You know anybody there at the time?
Yeah, well, there are Rationality chapter.
Oh, yeah, yes.
So here for
He arrived and I left a year or two later. But I was for a while, I was in like the governance section.
There's something that's going to
So we work with Link in Mark, who does sort of the government management and public policy. It's a separate institute.
You'd think that.
And yours, Nathan is here full time?
Yeah.
I always thought the same thing.
I think we're reform this first in the world. Department of Computation.
All right, let's gather up for the second half here. I would also encourage people to maybe come in a little bit. I think that it makes sense to us, and hopefully it makes sense to you. Rather than divide up into small groups, we'll just continue.
Yeah.
Amazon.
Oh, great. Thank you for coming up.
Okay, so Paul, take it away.
Well, we just want to really, I think we're all enjoying just this dialogue, and we want to continue the dialogue, really, and maybe make sure we talk more about issues of trust and ethics. But I mean, I think maybe the best way to jump up here is just somebody have a question that they're holding on to, they want to put out to the panel, and let's just keep going.
I know before the panel ended, you were going to ask a question if you were like.
Oh, great.
Yeah, actually, I was going to make a comment along the lines of what David then said before I had the chance to ask the question. I think that part of this problem of, see if I can remember exactly what I was going to say, part of this problem of making your line staff understand what the people in the AI are doing. I think it has to be evaluated project by project as to how you handle that particular situation. In our case, we're looking at enforcement in tax evasion, for example. So in order for a line person to understand, what we've done is we've created a dashboard for them. And what the dashboard does is it explains to them and uses the terminology they understand and they work with on a daily basis what the AI is suggesting. So if they're given a target, they know the probability that that target is a target they should go after. They know why the decision was made to classify that particular business as a target. And any other information that would be helpful in them evaluating whether or not they would feel comfortable going after that particular business based on what the AI is telling them the situation is. So I think pretty much with any type of project you put together, you can do that kind of dashboard between, or individuals between the AI and the middle manager to help them determine if that result is something they want to take action on.
And so it follows David's point.
Exactly.
The translation
Exactly.
function. In this case, the translation is the dashboard.
Right.
So it sounds like what we're saying are exploring is, we like this idea of augmented decision making. Then there's this. It's not just the AI and the human. It's the AI, human, and a translational person or thing, or it could be a boundary object. If we want to go in those terms. Yeah, please.
So we were talking a little bit. I just wanted to pose it broadly to the panel and the group. I've been thinking a lot about when to automate tasks within government from like things I mentioned like efficiency, effectiveness, and equity. And one of the things I've been trying to think about is what should be the criteria for when we should take discretion away from an expert. And so I've been trying to think of like different types of criteria for this. And one, building on some of behavioral economics stuff and psychology work, is tasks that we know experts do poorly, right? And so in thinking about when to automate a task and what should be the criteria for that, so I'll use one illustrative example, and I'd be curious what people think about. We know that judges, for example, suffer from cognitive biases like everyone else. We know that from some studies that before they eat lunch, they're more harsh. Right after lunch, they're less harsh with respect to sentencing and respect to questions about parole and recidivism. And recidivism in particular is one that has you have clearly defined data on people who come in and out of the system, their characteristics, and it seems like a space where even the kind of machine learning models that we have now can do a really good job of predicting who's going to end up back in prison and who's not going to end up back in prison. And we know that that's a type of decision-making space that judges actually just aren't very good at. They rely on their heuristics, they rely on their biases, they rely on whether or not they've eaten lunch that day. And so thinking from the ethics standpoint and like what government should do, are there situations like this already where the argument should be a little different? The argument should be the ethical thing to do is to go ahead and automate that decision, or to go ahead and have the algorithm have the default that then the judge has to come over. This is a really high consequence decision that we know experts do poorly. And so I was just kind of curious to the panel and to the group, as we think about when to intelligently and ethically use AI within government. Law enforcement seems like a pretty clear example. We know where people are clearly biased and have suboptimal outcomes, where we have some specific data in some cases that could probably already outperform judges on predictions.
I just want to comment on that particular study. This coming to question as to whether that's actually a legitimate assessment. So I mean, I take your point, and I agree.
You mean the judging after lunch thing?
I think the problem is that there was a lot of bias in terms of which kinds of cases were put up before and after lunch as a function of where they sat on the court docket, based on some expectation of how long it would take. So I think that particular one we might.
But there are a lot of other ones that support the same result. Not the lunch effect. In fact, that humans do poor jobs.
For sure, right? But that we're not quite as prone to being pushed around. Our needles aren't quite as vulnerable to being pushed around by recent circumstances and blood sugar levels as I think we had thought maybe 5 years ago. So there's been a somewhat of a revolution in social psychology to go back and revisit a lot of these approaches and look for, try to replicate and try to find some problems.
So the fact that I'm happier after I ate my brownie is psychosomatic?
No. That wouldn't necessarily change your decision at all.
Your ideas are not necessarily.
That's right.
But the broader point being experts are good at decision sets where they get immediate feedback, clearly defined. Recidivism may not be a good area where experts can do particularly well. If we have data that could do better, should the argument then be the ethical thing to do is to take that discretion away from the traditional experts?
One of my questions, especially in this type of example where you would need kind of that, personal touch in certain decisions, is, and these algorithms and considerations would be public, is would criminals in this case or other situations figure out, the algorithm? Okay, if I do this and I get, a degree and I'm, become faith-based and I meet all these check boxes, I know the algorithm's going to, give me a positive verdict. even though personally, deeply, psychologically, I know deep in my heart I'm gonna go, well, go do more crime. You know, are people going to find ways to cheat the system? I mean, not like they don't already, but would this kind of algorithm
Well, that's
be further?
the question is, yes, they do it already. So is this better or worse than what we have now? You know, it's not like we're comparing AI to no AI in some vacuum type situation. And we were talking about a little bit about that before. It's like, you know, are judges making bad decisions now, and could AI help them? Even if it didn't make the decision, could it sort of narrow the range of results? Like in this case, you know, it's almost like the sentencing guidelines, but for a wider variety of cases or a set of treatment modalities. I brought up an example that we have in one of our reports around treatment to reduce recidivism, and you could train social workers in prisons to give certain treatments that would reduce that, and AI can help you kind of narrow the band of that rather than say it's got to be the decision. It's sort of narrowing the set of decisions that a judge can run.
Let's focus on that. That's
Prevent the extreme.
Right. You know, the point is that there's bias. Is that human decision making, especially in things like government courts, has bias already. And another way to maybe think about this question is: does AI support mitigate that bias, or is it a more efficient delivery mechanism for bias? Yeah, because your example, Brad, of the maybe fault, which I didn't know, but if there was faulty data, I mean, that's basically somebody did a data analysis to come up with a model, and then if you followed what you said, just going with your idea that you're just thinking about, hey, after we implemented your model based on the wrong model, then the AI is maybe exacerbating bias because the research that underlies it was biased, was problematic. And so how do we know? I mean, how do we deal with this sort of, they're both biased in that last, I mean, people are biased, AI is biased. Are they biased in different ways? Can their bias complement and mitigate each other, or are they going to work together to make it even worse? And how do we know?
Yeah. So I think that the key point that I want to pick up on that you just made is that machines and people both have bias. And so that's why I think we want to have both. I don't think you ever want to have something that's 100% machine. And when you have the opportunity to have data inform a human, you never want it to be 100% human. But going back to this, the judges and lunch, there's also a study showing that judges in Louisiana are harsher on the days after LSU loses a game. I don't know whether it was football games, back to my concussion theme, but and now I'll go back to my construction analogy. That saying, when you have a hammer, everything looks like a nail. So I actually think that looking at the whole bias in how judges make decisions, I actually think AI is the wrong substitution. I think what we want to do there is have more data transparency. And I think, if I were one of those judges and research showed that I was more biased after my team lost a game, this is consistent with what the domestic violence studies show about football, when my team loses a football game. How can we use insight to then push transparency and push more objective, less biased behavior? I have to imagine that judges who are made aware of this problem with decisions that are different before lunch or after lunch, or different patterns, I feel like transparency and pushing information is a better solution to that problem rather than substituting. And going back to the original question of, when we know experts do a good job, should we sub AI? I actually think I want to flip that question around and say, gosh, in government, it seems like for every expert, there are, if you just think of a judge, for every expert, there are layers and layers and layers. And, in some systems, there are tens, and in some systems, there are hundreds of non-experts doing non-expert things. And I feel like it's those layers of work that we want to automate,
So,
not the most sophisticated. And the most sophisticated levels of decision making, we want to support with data and data science and decision science, but not replace.
yeah, so I think my general thought was that there are some things within an expert's domain that they're good at that they do, and there's some things within an expert's domain that they're not good at that they have to do. And some types of decisions, I mean, from behavioral economics and psychology, we have at least my understanding is a decent idea of at least what some of those tasks might look like. And so a decision about recidivism is not something a judge gets necessarily a lot of feedback on, just as this particular example, right? And so it would be hard to convince me that a judge is actually even good at it, even the best judges, much less, I mean, one of the things we were talking about, if you have a distribution of judges, you have all the ones in Louisiana who aren't doing a good job after an LSU game, maybe they're in the bottom distribution. We should be really concerned about experts, I think, in the bottom distribution that are making decisions that have such high consequence for people's lives. And in a lot of these cases, at least from my standpoint, right, even if the AIs or the kind of augmented information for delivering some type of default response, if it can get up to half, just being as good as a judge on average, that's better than 50% of judges in that domain. That's 50% of people making those decisions about people's lives. And I don't believe that judges, if you point out a bias, to them, are just, then they're going to be able to, one, change their behavior. It's not clear to me that often we can change our behavior with biases, but they have lots of power. And another thing we know from psychology is that people that have a lot of power have more confidence in their decisions. And so you might can change the percent performers of judges, but there's a lot of judges out there making a lot of crappy decisions that are harming a lot of people. And so it's, just thinking about the ethical dimensions of it, seems like there's a really good argument for taking the discretion away in decision-making tasks or contexts where we know experts are traditionally going to have a hard time, and in some way, but making the default be what the data tells us, and the judge having to have, compelling reasons for overturning it, and then tracking the judge's performance when they overturn the kind of default that the AI might deliver to them.
So let me jump in here and mention a little bit of background on this topic. I think it's an excellent topic. I think it's going to illustrate one important point here that we not discussed yet, which is that we all have this, I think, this quasi-hallowed notion of what the I is in AI. Okay, and I think here Chomsky is useful. So here, this is some of you may have heard this before. I apologize if you have, but some of you probably have not. So Chomsky says, what does it mean for a machine to be intelligent? So think about it. He wants a linguistically, defensible definition of intelligence. Okay? So here's Chomsky. Let's see if you buy this or not. Everything Chomsky says, you don't necessarily buy it. Here's how it goes. He goes. Birds fly, obviously. Birds fly. Things fly that are biological, and they flap their wings. They fly. Humans, Americans, we say that planes fly. Okay? Now, we say that whatever it is. Now, maybe in other language, maybe in Polish you don't say planes fly. I don't know. Planes fly. Fish swim. We do not say that submarines swim. It sounds weird to say that submarines swim. It sounds bizarre to say that boats don't swim. Right? Humans can swim at the surface of the water. We don't say that boats swim. So for Chomsky, it's a completely socially constructed term to say that machines are intelligent. There's no meaning to it. It's completely localized meaning to whatever your intuition says it is. But without definition, it's completely just artifact of linguistics. I say that for the following reason. It turns out that, and probably some of you guys have know this episode. So back in the 80s, a well-known social psychologist named Robin Dawes did this study with the Pennsylvania Parole Board. He demonstrated that, we talked about the regression models earlier, a very simple linear regression model outperforms the Pennsylvania Parole Board dramatically on recidivism in terms of will criminals be back in jail. So at the time, now it's saying it is literally a ordinary least squares regression model. Is that intelligence? Right now we're talking about this in AI terms, but now this is basically Dawes showed And there are only, I don't remember the detail, I took the course of it, there were only 2 or 3 significant variables. One of them was, did you get in a fight when you were in prison? And the second one was something like, it's not sure, it was something like, did you try to make a weapon? That's all that mattered on the regression. Nothing else mattered. Degrees, maybe there were no degrees back then. But I guess my point is to say that the reason, so it turns out that linear regression model halved the number of errors that the parole boards made. Now, the trouble is that regression model still makes type 1 and type 2 errors, right? It makes both kinds of errors. And it makes different errors than the parole board made. And so at least the first version of this, this played out in court in the 90s. I'm not sure which faction wanted it. So some faction in Pennsylvania wanted to use Daw's parole equation instead of the parole board, and went to court, and they got turned down. And basically, the rationale at the time was that different people would be basically prohibited from being paroled if you use that equation, and erroneously, because the type 1 and type 2 errors that were demonstrable. Now and back to the business about would the inmates then start gaming this thing? The thought was that, well, if they did start gaming it, you would progressively update it. You run the regression again, and you would get the adaptive behavior. Hopefully, that whole thing converges somehow. But anyways, so the point of that, this was an example then from kind of this is back in like the expert systems era of AI, okay, where people were using this is a trivial expert system, linear regression, and then it brought up this further problem that some of you may know. This guy was like a well-known social scientist, a competition named McCloskey. He was Donald McCloskey, but she's now Deidre McCloskey. And with the issue being that, so McCloskey says, a further problem with this thing is as follows, that the only 2 significant variables, statistically significant, were like, did you get in a fight and have you tried to make a weapon up at the metal shop? But it turns out other variables actually have explanatory power, but they're not significant. So the regression model removes lowers type 1 and type 2 error to put them in there, but they're not significant. So it's a social norm to not include those variables, but they do matter. And for McCloskey, this is this business about in the world of P statistics. As an example, by the way, an AI model, of course, is also going to have type 1, type 2 errors, right? And in the world of P statistics, you really the thing that we use these things about significance really as ways to measure not importance, but whether it's kind of scientifically defensible, right? And by the way, in the classic case, this is McCloskey's classic example is there is a well-known paper cited 1,000 times in economics about who are the recipients of traffic tickets. And it turns out things like, if you have a red car, you're more likely to get a ticket, et cetera. So one of the significant variables was you have out-of-state plates in your car. And for McCloskey, this is a classic example of where you're
more likely to get pulled over.
So it's statistically significant that out-of-state plates help you get a ticket, but it's economically unimportant in the sense that less than 1/100% of tickets are for out-of-state plates. While there are a whole bunch of other variables that are much more important, but they aren't statistically significant, right? So they brings up a whole bunch of issues.
That brings me to a question that I had also. Tax evasion is one of my areas, along with trade-based money laundering. And in both of them, looking at hundreds of different variables that serve as predictors of who's going to use trade-based money laundering, who's going to commit tax evasion, and so forth. And yet, you can't put all those hundreds of variables in one regression equation. It's never going to work. Isn't that
well,
one
you
of
can
the
do
areas?
it, but it won't be very powerful.
Exactly. So, isn't that one of the areas though where deep learning can help? Because we're looking at, on the one hand, what we've done traditionally, a couple of hundred instances in our sample, running the regression analysis. We find 4 predictors that do a good job of explaining tax evasion. Deep learning, instead, you're giving it millions of examples, and it's evaluating all of those variables at the same time and coming up with not only whether or not how those variables contribute, but latent variables composed of combinations of those variables and what impact they have. Isn't that where the real value of deep learning can lie in this type of an application?
But
It's simplifying and maybe allowing you to learn more about what it is you're seeing, what these predictors are really saying.
It's a much more elaborate regression model, that's right. But it's going to suffer this. You're still going to have the type 1, type 2 errors. And in particular, when you're doing basically, like also weights you typically use, is technically we call microeconometrics. So you're going to say, I want to know not just how many likely tax evaders there are in this zip code. I want to know, is Mr. Smith here a tax evader? Yes or no? So the deep learning model is going to give you that point prediction, right? So that's really microeconometrics. Right. That's opposed to. So this is the potential.
But again, it's compared to what? Is it still much more effective, even though it's going to make errors?
Mm-hmm.
Are the errors going to, and they may be different kinds, so they're going to be much fewer? And can you reduce the zone of uncertainty?
I have an example. I took data that I had used experimentally back in the day when I was the head of criminal investigations in Florida Department of Revenue. And I had done data at the time to figure out if different approaches to predicting evasion worked or not. And about the best we ever did was a 30% accurate prediction rate and tons of false positives. Mm-hmm. And that was the real problem. You don't want to go and prosecute someone when it's not warranted. That's the worst thing you could possibly do.
Yeah, I've had that experience.
So I took that same data and they fed it, the people that I consult with, fed it through a deep learning model. And they came up with predictions that were 1% off on both. 1% error and 1% false positives. Mm-hmm. Much better than we ever could have done as humans, just evaluating all those variables. And primarily it was because there was too many variables to evaluate. Even though you've got experts evaluating the variables, there are too many, and the interrelationships between those variables are way too tough to figure out just thinking through it. Yes.
I could comment on that. I think a good intuition to take forward when you're using deep learning approaches is that the accuracy is around 99% for a complex problem is just don't believe it. And the reason is that it is very easy to accidentally overfit, even if you're using cross-validation and various other approaches that are typically thought to prevent overfitting. Those approaches are only effective if you're only attacking the problem once, that particular data set once. And then if you were going to tweak the hyperparameters of the algorithm, then you'd want effectively a different data set. So I think that there's a real data limitation when it comes to tweaking one of these deep learning approaches, because it's so easy to accidentally stumble into overfitting territory.
And there's also a corollary to that one too, which is basically a corollary would be something along the lines of, imagine that, for example, in our parole board example, imagine that for whatever reasons of fairness or congressional mandate or whatever, we decided that we don't want to have race be one of the variables in that parole equation. We don't want to let that enter in, even though it may be significant. We'd have to just, for whatever reason, not put it in. Now, when you do the deep learning algorithm, you're going to stumble across covariates of race. You're going to end up with a race equivalent in there, even though you didn't want it in the first place. So you have no control over it when basically you're sampling all those different combinations.
That's right. But that all that said, I think that you raised another really good point about these latent variables. Rather than using such approaches as a substitute for human decisions, if you train up one of these deep learning approaches and then you explore effectively the latent spaces that it creates in like layers 50 to 100, you might be able to discover new latent variables that the investigators hadn't appreciated before, and then take that and factor that back into the human side of the equation.
And actually then feed that back into the algorithms can learn from those they can sort of create a smaller zone of uncertainty because they've learned from an error in the past, so they know sort of how to spot that. In other words, they can reduce the error rate over time by learning. That's one of my definitions of intelligent machines is the machine can actually learn from its mistakes. Or more correctly stated, the humans have written algorithms that allow the machine to do its computational results more effectively.
So I had a question. I don't know if it's passed or if you wanted to.
Well, I mean, there's about 600 things you could choose to focus on. I guess from a practical standpoint, there are folks in here from government, but for those of us that are in higher ed, as researchers and teachers, I think we've got a data challenge. So we're talking about the values of big data, but getting it, cleaning it, managing it are really enormous tasks for your average person engaged in trying to answer complex questions. And obviously there's going to be trade-offs for governments that adopt, even in GAO, your efforts, all this energy towards what your agency is trying to do is not going to some other thing, right? So there's trade-offs, and we haven't really talked about, what we might be avoiding when we choose to go down this road. But right now we're marching, right? We're more than marching. We're cruising towards AI growing in society and also in higher ed. So I think the question for teachers and program managers at both the master's and the PhD level is, how do you prepare students and faculty to actually understand data? Like, for example, if you want to get IRS 990 data off of Amazon Web Services, you have to do code to do that. It's publicly available, but you have to actually build an interface to grab the XML data from there. So, okay, I just became a coder, right? And I just built an app to get that, and then I had to build a database to house it, and then I had to. So I guess my question for you all is, practically speaking, if we're going to take advantage of the insights that big data has to offer us, how do we do that in the settings that we have? I'm in public affairs, public administration. How do we do that? Should we be teaching students to code? Should that be a required course? Should we be teaching students to use databases instead of, we have massive reproducibility issues, and I think some of those are based on really poor knowledge bases about how you actually manage data once you have it. And there's tons of other things that we could bring up, but practically speaking, how do we leverage big data for research, given the challenges that we currently have? Transparency, Jane brought up, transparency is great, but the problem is it's too transparent once you get it. You can trace back, you guys all saw that New York Times article, I hope, the one where they traced a woman to her name, to her student, to her child's school. You can get so granular with these data that immediately we've got privacy issues. There's the institutional review boards that are getting prickly about stuff. So just practically speaking, how do we get in the door of big data given those challenges?
Coding, not calculus. In other words, a lot of students are learning things that they will never use in life.
Right.
And this is part of the, if we think about it, this isn't just a higher education issue. This is a
true. Right. I'm speaking of it because that's where I'm at. But had I been given coding when I was in school,
right. I now think, and obviously I work at IBM, so I'm probably biased. But I tell my kids they really ought to learn the basics of coding. Whatever their field is, it's going to help them because they're going to be using the result of that in the future. And I think that if we think about what are the key aspects of sort of big data analysis, and we think about how to build that into curricula, it might be that it's going to take 10 years for the public administration and groups like the Voter Alliance who are working on curriculum in universities to kind of filter that down. But I think it's the right question to ask as to what are the skills that we need to be teaching, even in the elementary and secondary grades, that you can build so you don't have to have people that are stuck in the sort of place that you're describing.
Well, and ASPA, I don't think currently has any recommendations regarding the requirements for computer coding. And for example, ethics classes usually get short shrift. They're going to go out the window when you add coding requirements. These are the challenges I think that we need to be grappling with as we prepare students to enter government, if that's where they want to go, or nonprofit management, leadership, or even higher ed. And I just don't think we're meeting it right now. I agree with you. But that's like the future. Yeah. And I think kids are getting it actually.
More and more.
On this point, I want to just descend a bit. Let me just say, so I run a PhD program, computational social science, where about half of the students are computer scientists who have to learn social science. and the other half are social scientists who have to learn enough computing to be dangerous.
Okay.
And
That's exactly right.
those social scientists take a lot longer to get good at, to get good enough to finish their PhD. Maybe it's like 4 years to completion versus 6 or something, and it's a fair size difference. But I mentioned this because I think that at the research level, yes, coding, and when I was a graduate student, when I was undergraduate, everybody said, you know, going to computer science, it's all about programming, coding. Here's what I think. I think my sense is that, particularly for somebody who works in government, who's not going to be a PhD researcher, but you're going to have someone who's going to need data. My sense is that the future is going to be something like, you know, a smart app for your data.
Yeah.
So basically, you're working at USDA. Here's an example I know a little bit about. There is a server in Springfield, Virginia out here, which has every Snap transaction on it for the last 15 years. That's $80 billion a year. That's $1 trillion of transactions sitting on one server. And it's not going to expect every single person at USDA or in the SNAP program to be writing their own code. You don't want them writing their own code. But what you want is, so they basically hire.
SNAP is school nutrition for those of you.
That's supplemental nutrition assistance program. So the idea is that USDA hires an app builder to build hooks into those data.
It's a dashboard.
Smart interface.
A legacy problem.
And then that smart interface is something which, yes, all the kids today can use that smart interface.
That's a fair point.
Yeah.
Well, I think
Right.
No, and just part on the other side, I've run into that problem too. That's my first year. Is some of the older professors, I'm like, well, I can get this data, but it's all going to come out in this weird code. And I'm like, can you help me? Like, what are they talking about? Go ask them in computer science. And they don't, at the same time, aren't able to help with some of those kinds of instructions.
So Rob said something about learning enough to be dangerous, and I think that's another crucial point, is that it is so much easier to do analytics wrong than it is to do it right. And it is so easy to write or some kind of approach that gives you the wrong conclusion with an inscrutable middle that you then trust because you can't sort of trace your way back through it. So I think in addition to either coding skills, or I think Tableau, for example, is another example of a sort of dashboard visualization engine that kids could use, or students could use, except it's very expensive. They also need to learn somehow, we don't have, I don't think, hardly any training programs, an emphasis on not just getting results, but figuring out some way to make sure that it makes sense. I don't know how to do that.
Download it, right. Sure.
And let's also not forget the other half of it, whether it's easy or not. It's also very possible to do social science poorly, or to think you understand social science and not understand. So to think it's all about doing a survey or whatever, right? I mean, we run into that all the time, right? If you're in the social science field, people from a natural science perspective generally minimize what social science involves. So I just want to put that in there, right? It's not just that social scientists or everybody needs to get on the data side. I think figuring out ways for people to appreciate the social dimensions of complex problems is equally, or the ethical dimensions, and not forgetting that is equally part of this equation.
You know, these questions are so relevant to a number of you talked about regulation. We haven't really talked about that on the panel, but when we run around the room, and there's the whole sort of policy development, regulatory aspect of how are we going to move forward in an AI-enabled world, and having people in public administration sort of have enough skills to understand the impacts of AI as they're writing policy is something that I don't know that we've given that a lot of thought as a community, but it's one that I know that Jane's done some work on this with some chief data officers, and that the sort of the rules that they write in agencies at the federal, state, and local level, we need to sort of think about that from different regulatory programs, whether it's environmental protection or rail transportation or aviation safety.
That's really well said, because this is exactly the public affairs programs and public policy and MPA programs are doing. Basically, they're training that workforce that's kind of like working in the city. I mean, a lot of people from my program are graduating, they're working in the kind of like state government or like feds or local governments. And I think at least we are making the move to like have them at least some awareness of not necessarily hardcore coding, but rather at least having understanding of that kind of like a dashboard and interface, like I understand the assumptions behind that, and or also understand the assumptions in that black box of deep learning, like what is like I think like having that knowledge could really help. But public administration and ASPA needs to move both NASPA as well as in some sense to change the curriculum requirements so that they're at least familiar with or comfortable with these technologies and understand the limitations.
James,
yeah.
go ahead.
And so, oh, yeah?
Yeah.
I was just going to pop it with, I want to draw a distinction between, and I agree with just about everything that's been said. I think that in terms of how do we prepare for the skills and talents we need, I think we need to do all of what's been discussed. But I want to draw a distinction between the doers and the deciders, right? So the doers are the ones who actually need to know how to code and who know how to work with data. But the deciders need, you know, and these are the executives, managers, people who are trying to make decisions based on the data. I think they need different skills, and it's, to me, it's two things. It's the confidence to not run away from this stuff, and I see this in clients of mine where the millennials, you know, they're building story maps, they want to do analytic models, but the baby boomers are, you know, they're afraid of that stuff and they just ignore it. So we got to bridge this gap by building the confidence. But I also think that curiosity is a big factor, which is that the decision makers have to be able to say, hey, like, what if we explored the data set in this way? What are the questions we can answer? How could we take on this policy challenge with data, with AI? So anyway, I just wanted to make sure that we realize that the skill needs are very different for the doers versus the deciders.
Yeah, I guess I'll say something here. So you're talking a little bit about ethics and and related kinds of things. And so just to sort of translate that into my environment working at the GAO, we have an acronym, AIR, which is accountability, integrity, and reliability. And those are, I guess, 3 guiding principles. And so what we have at our agency is a very elaborate quality assurance structure, where I guess maybe one of the key principles is that every word, every sentence that goes into a report has to be directly sourced. And there are multiple verifications of this that go on, cross-cutting. There's a whole array of stakeholders who are involved in this process. And so it's very manual. And so if we start trying to introduce kind of automation into our data collection and reporting process, it starts to run up really quickly against that set of quality assurance standards. So for example, I'm involved in a project right now where we're looking at financial or policy and environmental disclosures in 10Ks. And so we want to be able to say in our report to what extent and in what ways are companies disclosing, for example, environmental potential environmental effects on them, or maybe environmental effects of their business. And so how are we going to do that? And one way that we're thinking about doing it is to automate the process of reviewing 10Ks to come up with an answer to this. And we found a model which is out there that's been developed by SASB, Sustainability Board, Sustainability Board. And they've developed a machine model that categorizes the financial or the environmental disclosure information that's contained in 10Ks. And the sort of categorization that they use is pretty crude. It's sort of like one of the categories is boilerplate. And another, then there's like a qualitative category, whether or not they're disclosing in some more substantive way qualitatively. And then there's a quantitative category that's sort of the highest level of rigor of these disclosures. A lot of it is boilerplate in 10Ks, but we're considering using that. But when you look at that from the point of view of our standards, it may not pass muster because we don't know for sure that this categorization is what we would ultimately agree with if we were to look at it anyway. So that gets into this integrity issue because we come under a lot of political pressure with what we put out. So we have to be so our standards set us up to be as sure as possible that what we're putting out is well sourced, well documented, and verified. So that's just an example from practice of the challenges of using machine learning in a kind of an analog organization.
So you might like a report that's completely sourced, and then the output of that report gets fed through a deep learning mechanism.
Yeah.
And then you have an answer, and so you can say, well, everything's still sourced, except that there's this big question mark in the middle.
Yeah. Well, one of the I was at OMB for many years, and so I had a lot of interactions with GAO. And one of the things, even with the sourcing, anytime GAO does an investigation or audit of an agency, yes, it's very transparent. The agency may still come to a different conclusion. There's always at the end of the GAO report, you'll see a letter from the agency where they say, well, we disagree with the following conclusions, or you'll often say that. But the
Which doesn't necessarily have a lot of impact.
But the reason I bring this up in an AI context is that the transparency of the algorithms could be done in a similar fashion. If somebody's doing sort of an AI-based sort of analytical investigation, an IRS investigation, or what the algorithms were, what data they were based on, so that there's transparency and traceability for the user and the subject of the investigation to be able to trace back and say, yes, we agree this is a fair result or not. And I think that the GAO methodology, I think, is a useful construct to think about how do you translate that in analytics.
Yeah. I mean, we have a chief science,
Tim Persons,
yeah. Chief science officer. Yeah. And one of the things that in the past has been a really a critical concern, and we have these international peer reviews where, like, I don't know, France will come, the French SAI will come and they'll do a review of 50 of our reports deep into the documentation, and then they'll identify maybe some things that need improvement. And one of them one year was data reliability. So we use all kinds of data in our reports, but we weren't being as transparent systematical in assessing the reliability of these agency data that we were getting. So that became a whole movement within the agency, data reliability. So we developed these, manual pretty much standards to check the reliability of the data, and they ranged from lots of different data testing, but also interviews with agencies, reviews of documentation. All this had to be then documented. And but Tim now, our chief science officer, he's interested in bringing a big data orientation to the agency. And he's concerned that if we maintain that data reliability framework, it's going to be a block. It's going to substantially hinder our ability to do that. So what he's interested in is trying to develop complement the existing framework with new principles and standards that would allow us to still have some surety about the quality of big data we're using, but obviously you can't use simple data testing techniques to assure the reliability of massive big data kinds of sources. So
on these 10Ks, I am familiar with a couple startup companies that are trying to mine those things, and one of them is funded with the Sloan Foundation to actually provide richer data than you would normally find there, basically do a machine interpretation of kind of longitudinal information instead of 10K and draw conclusions. So I wonder if you guys were to use it, because I just looked up opencorporates.com. Opencorporates.com is funded by the Sloan Foundation. If you were to use their summaries as secondary sources, then
they could source it.
Exactly, right, yeah.
It's really interesting.
They're a nonprofit and just a startup one. But they have results already.
So we haven't gotten very philosophical today. And one reason to avoid that in some ways is because it's coming and deal with it, right? But we haven't been very philosophical in thinking about what the human implications are for AI. Do you want to talk about that? Like, what should be our role in urging government to address these issues as academics or researchers or whatever? Is it, when you call in and you get a chat bot, I had mediation training. I used to mediate small claims courts. Like, you could probably program a chat bot to know how to address someone who's unhappy. Tell me more about your problem. What else would you like to tell me about your problem? Right? You could program an AI to do that. Are you losing something ethically, or does the person get the benefit from it, of that process anyway? We just haven't really gotten philosophical hardly at all about things that are deeply philosophical. Is that because you guys don't think it's worth talking about, or why? Because
so
you don't want to.
That's highly worth talking about. I was actually, again, at the break talking about an application that actually operates like what you're describing for veterans who are at risk of suicide. Right. And it's actually a self-guided app that some folks at IBM have developed that takes them to different resources and asks them questions and sort of says, if you're in a bad mood, maybe you want to take a break, take a deep breath. I mean, it's sort of trained, the algorithm's trained to respond to certain types of considerations. But and the question again is, what is is that ethically less responsible than letting somebody suffer who doesn't have access to, let's say, a resource, right, or they can't get to a social worker, if that's the alternative. A different way of thinking about this, just a preview of a report that's coming from our center in about a month, is there a University of Michigan researcher named Yan Ong did an analysis of big data and sort of on its own, and then linked with ethnographic contextual data to understand sort of how, when you do an analysis of a big data, basically a big data set, and you try to deliver a treatment modality at a local level, you're not going to get as, I don't know whether it's an ethical is the right word, but you're not going to get as well crafted an intervention that suits the people that are receiving that service. So she actually looked at like people that are receiving health services in Africa, and they were using a data set around sort of treatments across multiple countries, but they didn't really think about how people receive that data. So only when they got into the ethnography of the local recipients did they understand how to apply the big data in the treatment sense, which is a different form of an ethical consideration. Back to your first point, I do think it's, the genie is kind of out of the bottle. And so it's more, maybe one of the reasons we haven't gotten into this, we could probably get into talk about this for hours, especially if we bring the wine up, is that it is coming, and the question is, how do we deal with it most effectively? So none of us, I don't think any of us are philosophers.
And what spaces do we protect from it? I mean, it may not necessarily need to come to all spaces. Right. And how do we, critically protect the spaces where we're not comfortable with it, or we're only comfortable with it in certain ways? I mean, the thing I'm, just following, like the moral machines example and self-driving technology. We can obviously imagine, like you said, that self-driving cars will ultimately be safer than human driving cars in the aggregate. You still have a AI or an artificial intelligence making a decision to kill somebody in certain cases over
that results in somebody being killed.
That results in somebody being killed versus some other thing happening.
Right.
And obviously humans do that, or their impulses do that, or whatever factors go into when a human swerves or doesn't swerve in a particular situation, and somebody may die. And I think about the other side of that, again, what I was talking about before, the implications for the human society, for the family, for the person that's driving, or for the person that's a family member of the person that was hit. And it seems to me that there's so much that goes on when a human driver does that we're prepared to deal with. Like, we know how to blame somebody, or, take out our anger on that person.
Or justice, the justice system.
There's the justice system. We know how to grieve when there's a person involved. I mean, to somehow like, even though it's a horrible thing to be the driver in that situation, you're somehow, the fact that it's a human being, there's something happening there.
Why is that a different problem, though? I guess to square by why is it a different problem from the Manchester City of 1900? Edison has now electrified a dozen cities in New Jersey. You're the mayor of Camden. You're saying, I don't want that goddamn electricity because someone's going to get electrocuted, like that guy over there. Well, what's the difference? It's just there's every technology has its problems, and it's going to.
The difference is that you're making specific decisions about who will be electrocuted. That light bulb itself is deciding at some level who's going to be electrocuted. I mean, it's not like it's not.
You're anthropomorphizing with the machine is just calling it.
Well, I am. I'll admit that, but I think that's what that is kind of my point. Whether I am or not, and whether maybe I can be educated to be less anthropomorphizing, society is going to anthropomorphize, and the implication of society's anthropomorphizing is going to have issues, right? So maybe I'm anthropomorphizing, but we are going to anthropomorphize, and it's different when a machine kills a person and a human kills a person. The grieving process, the social fabric. There's different implications. So I agree. I'm anthropomorphizing, but yeah,
happily,
we're going to.
Let's think about, I'm so glad you brought that up, the difference between how we view what a machine does philosophically versus what humans do. And, if we can just look, there are 46,000 highway fatalities a year, and most of us don't focus on any one of those, and yet we all know about the autonomous vehicle that hit a pedestrian. 1 out of 46,000 is the case that is the one that we all think about. Something that's on my mind is the death penalty, which is a situation where we know statistically that humans are making mistakes. There are innocent people who've been killed through the death penalty, and yet somehow that isn't keeping people up at night the way the potential for AI making fatal mistakes is. And so I don't know why I'm throwing that in there other than to say that I think this is philosophically complicated, and we're really absolutely just at the beginning of figuring out how to understand it. And for me, where I go to is the question, compared to what, right? If a machine does this, is it imperfect? Yes, but compared to what? Compared to just a human being more imperfect? Then if we're getting incrementally better, then my compared to what is, oh, okay, I accept that.
Imperfect humans can be replaced through political processes or through firing somebody. And imperfect AI, I mean, I guess it can be updated and it can be learning, but it's a different process of replacing it. You can ask the philosophical question and then leave, huh?
Well, you know what? I mean, I guess we don't expect humans to be perfect, do we?
No.
But somehow we expect that of the machines.
Well, with regards to the self-driving thing, I think that the question compared to what, though, is that people who've done statistics, I think actually the driving rate, the record of autonomous vehicles is actually worse per mile driven than people are.
Currently.
The number,
That's right.
currently,
Yeah,
obviously we'll get better in the long run, but I think they're currently way worse per mile driven than people. The National Traffic Safety Administration analysis, and their analysis actually came up with it was a really clever analysis. They looked at Teslas that had the autonomous option activated, pre and post that activation, to see how many times the airbags were deployed, which is a great control group because it's the same driver in both groups. And the problem is that their initial analysis showed that there's a huge drop in airbag deployments, but it turns out that that analysis was deeply flawed because there were a lot of empty cells in the Excel spreadsheet, and they hadn't interpreted them correctly. And this is where we get to that issue of people doing analytics without really understanding what they're doing. When someone used the Freedom of Information Act to get that data from the NTH and reanalyzed it properly and found that actually there was an increase in the number of airbag deployments in those cars that had the autonomous system activated. So I think
the higher insurance rates for Tesla drivers. You can use that.
Is it actually? Yeah, you can trust the insurance companies to do the numbers better than anybody.
The other sort of vector that this all plays out in is the assignment of liability in a legal setting, right? It used to be like, driver hit somebody. There's an understanding of how to address that in a legal setting. If it's autonomous vehicle that was programmed by one company and has a computer system made by another company, and the car is built by a third company, and the autonomous vehicle hits the person, and how do you assign that liability? We're nowhere near sort of understanding how those
So that's the David problem of accountability, integrity, like, where does the buck stop?
Yeah.
Well, with the Deepwater Horizons thing, right, that accident, I think it's sort of tracing down to, and it came down to something like the concrete manufacturer was eventually found liable, or something like the human decision makers were taken out completely as a material defect.
So it'll take time to evolve all that, but does anybody question the fact that it will evolve, that it will evolve new legal standards?
I think we will.
Yeah. Just as a footnote on this one, I bet you mentioned the electricity example. Does anybody know how long it took? The first cities were electrified by Edison in the 1890s. How long until half the U.S. had electricity? I know this one because across from Brookings is the Rural Electric Cooperative Association. So they had a display of 1937, you got half. That's 40 years to get half, more than 40 years to get half. So these things take a long time to play out.
Especially to get over Edison's obsession with DC.
That's what we're talking about. Westinghouse had to come in and fix them.
Of course, iPhones took a lot less time to have ubiquitous.
There was no legacy technology.
Yeah. There's a person who I wish was also in this room, Joanna Bryson, who's a computer scientist / philosopher at Bath University. She's done a lot of thinking about sort of how we should approach the development of robotics moving forwards. So I haven't read up deeply on everything that she said, but I think it's sort of in a nutshell. We have some ability to sort of steer how the ship is going. It's not just like this inevitable wave of AI that's coming forwards. But the sort of one of the mainstays of her position is that we should continue to maintain the idea that robots are property, rather than thinking of them as something that eventually we're just going to create and turn free, like you see in a lot of science fiction proposals.
Yeah. And part of it, I think too, is that at this point, it's, especially for the public, is that the fear of the unknown and the fear of not knowing, electricity, there was that fear of it with AI. They're focusing on this one Tesla crash because of this potential fear of unknown and how scientific movies play, right? Into that understanding and logic of, citizens and what that really means, and what, we're all going to be, my mom thinks we're all going to be running around like the Jetsons, and, no, and so these kind of, how does the,
I think there's a gruesome, horrific aspect of it too. Like, for example, the most recent one, the Tesla went under a semi, just tore off the top, and the car kept driving for a quarter mile. And so just the idea that there's this car driving itself with a headless person in it is just inherently horrific.
One thing I guess I wanted to say, you guys just touched on it and sort of said, oh yeah, new standards and principles will develop. So that was what I wanted to say essentially. So, and it might take too long. Like in the case of climate change, which is the whole set of findings that we have and our knowledge about it is very much big data based, right? And but we're running up against fundamental problems with our system of governance and our democracy in trying to deal with that problem. And just having to do with, you can even look at our current politics and the sort of willful ignorance of all of that. And so how do you, that it may be too late before we figure out the new standards that would, enable us within our democratic framework, yes, to make systematic and systematic use of expertise and data, so that's one area. But I can imagine that you could have other case studies like that, which would bring that assumption into question, or so.
Things can get out of hand. I mean, if you're alluding to that, for example, law enforcement agencies have been given the option to test some of these like drones so for example, if a police official has to go on a crime scene and can like put their life at risk, they can just send drone or a swarm of them. So there's a lot of research happening on the swarm operations. So you can send like a swarm like controlled by agent-based models or whatever. They can kind of like determine the situation and then kind of like identify the person that needs to be taken out and do that, right? So they can be controlling them from behind, or those swarms can be trained to act on
semi-autonomous.
Exactly. Yeah. And similarly, like in the fire suppression technologies have already proven some of those swarms have been tested in California. They did really well. Those swarms were much better in controlling the fire than the humans were, in terms of, because their view was not there, because the drones could just fly at the optimal level and see the span and identify where they need to do the intervention to really control the fire. And that was based off an agent-based model that was trained on fire suppression dynamics. And then they were able to use the swarms to kind of like use really minimal resources and just take out the fire. So I think all these kind of technologies have a great potential in the sense that to augment the human and the policy and public administration and management fields. But then the question is like, things can get out of hand, right? I mean, that's where the ethical things can live. Probably, David, you were alluding to that. It's like, it might be too late. Like, say, we give law enforcement officials those swarms and they might use them. I mean, in some countries, it's very much possible that they can use it for personal vendettas or other kinds of stuff.
Yeah. I think the misuse of algorithms, especially in the political context, as David brought up, both what we've seen in the last couple of election cycles and the risks of foreign actors misusing them. Obviously, that's a risk. We can hopefully be ahead of those risks and work with data scientists, data analytics, and people who are engineering algorithmic responses to be ahead of those risks. I do think the climate change is a little bit different. I share your somewhat existential concern about this, though I think that if, from just a big data perspective, the knowledge we have is independent of the cause of, if you believe that human activity over the last 200 years has kind of increased in terms of the environmental impact, the fact that we have the big data that shows that it's not related to the cause of the pollution that's creating the effect. It allows us to know about it, and it may allow us to kind of have the warped knowledge that we're too late, which we wouldn't have had if we didn't have the big data. But the climate change still is more of a production process issue than a data issue.
But I think it's worth mentioning more about this point about kind of bad actors in the system, though. So let's mention that. I've heard rumors about some large state actors. Let's front about say China. Maybe they would use deep learning to figure out, in almost a pre-crime way, right, to figure out who are the dangerous citizens in their country and take actions, even on the forecast, who are the likely criminals, or that kind of thing. Just a very concrete example of this. So I was at a research conference in China where there were several papers about crowd control in China. And what they're talking about was they were basically models of putting, they call them shiv actors, where they basically had government actors inside a crowd to keep the crowd from doing something it shouldn't. They didn't want it to do, right? So as we can imagine, there are whole lots of.
You mean they had shivs?
Yeah, right. A whole bunch of philosophical implications. When the powerful state involved, we can get access to these powerful technologies and things that we would never do with them.
I wanted to ask a question about the agency thing again, which I think is really interesting. That we have this sort of like human agency is this very sort of sacred idea, and the question again is why is that? We talked. I mean, it's not just that the human brain is inscrutable, because deep learning mechanisms are also inscrutable in the same way. We talked about the fact that it could potentially be about accountability, but there are a lot of people who are not accountable and still have that sense of agency. And I wonder if another part of it is just that we sort of hold our own agency as being sort of sacrosanct on an individual basis, and that we then sort of assume, therefore, that we don't want to lose that agency for other people because it also sort of threatens our own internal agency.
Even if it's a myth.
Yeah, even if it's a myth, right? And so there was like we were talking before about the idea of sort of presenting people evidence that they're biased and maybe they can correct that. But I think that actually experts would be very resistant to taking any lessons from that. I work with radiologists, and we're who's thinking about sort of building ways to detect if radiologists were mind wandering while they were scanning someone's scans, because there are cases where radiologists can sort of tune out like the rest of us and miss like some very obvious tumor that in retrospect it's not even remotely subtle. It's just like a quarter-sized white circle. What happened there? Well, their brain probably flitted off like the rest of us, but they'll never admit that in a million years that they ever do this, because it sort of threatens their agency as experts. So I think that I wonder if that's a part of all this, is our sort of internal belief about our own sort of supremacy and how we evaluate.
But back to Joanna, as long as there's some human who's has to take responsibility for that agent, for the intelligent agent, then I think, are we okay? And I mean, we have examples today of, for example, high frequency trading on Wall Street. Every time, if I deploy a bot to trade and I lose a bunch of money for me, then it hits my account, right? I mean, that's the way that the hedge funds work.
Well, but with the open source, I mean, you could imagine someone develops something, just releases it in the public sphere, and then that person just put that information out, or someone else can just download that code, copy it, and implement something. Sort of, you can't really. I guess you can blame the person who downloaded it at random, I suppose, in that case. But the original author, sort of, I just put it out there.
So I think this is really like getting to. I really appreciate the panels, like very insightful discussion and kind of like this conversational approach. That's exactly what we wanted, and I really appreciate your time and effort to be here and kind of like engage in this really critical topic. And I think this is not the last of it. This is the first of these issues. So we're hoping to kind of like continue this discussion in some shape and format in more institutional level in ASPA and some of these other public policy conferences, and hope to engage you further in some of those initiatives. And I'm also hoping to have some kind of like an editing book proposal. There are some publishers who are interested in more like in this idea of like advancing public service and what are the challenges and issues. And I know like you've already done a lot of interesting work, but they're looking at more broader spectrum, and we can kind of like maybe talk about that at some point in time as well. And those of you who participated, you're welcome to. I'll send around the ideas, and you're welcome to contribute. And I'll send that, share that with everybody on the list.
There's a session. I'm sorry. There's a session tomorrow that I'm speaking at that's on this similar topic, but you all are going to be much more expert than. That's a 75-minute session. After 4 hours here, I'm a lot smarter, so I want to thank everybody for that as well.
Absolutely. I mean, I think this is the 4 hour, that was the intention, because some of those conference sessions can be like 90 minutes and rushed and kind of like not an interactive discussion. And the idea was here to kind of like engage in. I think you really did engaging with you.
Yeah. I have questions. Actually, I'm not sure if my questions be overlapping with the previous questions that you have discussed because I was late. But I have two important questions. And first question is, our field, the PA field, is still very data-driven, theory-driven field. So, for example, for two top journals of PAR and JPAR are very, very theory-driven, and I've been applying for journal publication to that. I mean, that might be because of the quality that my study is, but still the topic itself, mine is Monte Carlo simulation study because of the lack of the empirical data. So, but I've been applying for the journals, and then they seem not to be very interested in this kind of data scientific approach. So I've been rejected even in the ASPA for 2 years. This year I eventually got accepted, but I submitted 2 different papers, and then the case study got accepted, so I could get a chance to come here. But I was wondering how. I mean, I want to be an efficient scholar in our field, and I have to publish those studies. So how can we? How our approach of using these data-driven tools can be compatible or incorporated with the current atmosphere of theory-driven atmosphere. That is one question. And second question is, I actually got empirical data, related to human decision and task decision related to educational policy. But the problem is, when I got the data, actual data from University of Oregon, it's really, really messy, So somebody already mentioned that how could we get the coding? I mean, I took like more than 100 credit hours in statistics department in order to get the, statistical ability and also data management ability in addition to SQL. But this is really, really messy, so I couldn't do it. So in this case, should I give this data to outsourcing, like a computer science people, or what can I do? Because I know this is really important, in order to survive in this field, but I have no idea what I can do for the next step.
That's a really interesting challenge for here earlier. Jane talked about the data builders and the data doers. The data doers and the data, what was the other group, Jane?
Deciders.
The deciders and the doers. So there's a third group, which is the studiers. And it's almost like there's a different set of skills from a public administration scholarly perspective that doesn't, and it kind of relates to both of your points. Peer-reviewed academic journals that are relying on sort of theoretical constructs are not going to be able to understand the value of that research that you're proposing. And it's almost like it's almost like another version of the law will evolve. It's like scholarship will evolve. And you probably, I'm thinking practically, you want to think about collaboration with, and like your program is a great example, collaboration where you've got social scientists and computer scientists working together. And it may be that in your case, as a public administration scholar, you bring in a data analyst and maybe a computer scientist and do a joint publication. And it may be that there's a journal of computational sciences. I don't know that world, so I don't know if that's a journal. But it might be a more appropriate place for that article, but then you could do an adaptation of that into something that a PAR or a JPAR might look at. But just a couple of thoughts.
That's great. So do you want to please?
No, I was just going to say, I mean, it's a similar kind of dynamic in sociology, and I don't know what it'd be like in psychology, but yeah, very theory driven, which I come out of sociology, and even today it still is. If you look at, the main journals, there's not a lot of computational work that gets published in the primary sociology journals, and but you do have kind of sub-disciplines within within sociology of Michael Macy and guys like that who they do publish now and then in sort of HAS and whatnot.
ASR.
Sorry?
ASR.
Yeah, an ASR, yeah. But yeah, that's a big challenge, and my agency is not theory driven, but we have an analogous kind of problem as well, where we're kind of driven by kind of laws and standards or regulations in what we look at, and kind of data driven approaches. And, that's a big challenge also.
If you view it as a new methodology, I had this discussion with a couple of different people that every new methodology will eventually need a new journal. Okay? We'll say, okay, early on there were no journals of game theory. Now there are. There were no journals in experimental economics. Now there are. There were no journals in computational modeling, database modeling. Now there are. The issue is if you do it too soon, you make a ghetto. You make a place where all the crappy work goes, right? So you want to do it eventually, but you want to first get approval from the main scholars.
Yeah. So I think this is a perfect note to end this. Thank you so much. I really appreciate it.
Thanks.
Jane, thank you so
Thank
much.
you, Jane.
Thank you. I'll follow up.
Thanks. Okay. Bye.
Bye.
Yeah, University Park. Yeah. I'm like,
Enjoyed that.
Yeah.
Thanks so much. Nice to meet you.
okay.